It seems pretty stable now. Maybe we're good for the rest of the night. Maybe
I
OBS.
literally knocked on wood, so
Maybe OBS just needed a little wake up call.
Well, you did clean up like 21 gig of files. That may have helped too.
Well, that was just on the hard drive, so I mean, I can't imagine that my hard drive being at 70% full versus 65% full would make a difference. But maybe it would, I don't know. All right, what am I catching on here? Catching on you.
Right. So I assume we already have a replacement for the cap that went kaboom.
Yes and no. So while we were having stream issues, I was talking a bit about this. I have this replacement. So this is the original cap is quite big. I have this correct form factor, although a little shorter cap, which unfortunately is the wrong capacitance. This one's 4 microfarad, this one's 5 microfarad. And then I have this one, which is 4 microfarad, but the wrong form factor.
I would go with the wrong form factor one first, because this is a Ferro resonant setup, and those are tuned circuits.
I get what you're saying, except that requires like cutting and splicing of wires. And I have the correct form factor in 4 microfarad. It's just not getting here until like 3 days from now. And I ordered it a full week ago.
I would want to check the outputs of the transformer then before you do anything. Because if the core saturates at a different point, the voltages may change.
Yeah.
Well, that's why you've got a regulator on them, right?
No, the whole point of a Ferro resonant transformer is that the resonance is your regulator.
No, but you still have you still regulate them to a specific voltage after that.
Right.
Some of the rails.
Yeah. I mean, it can't be any further off than it was when we were running it ghetto before. I mean, I'm happy with like slipping this one in there. That doesn't bother me. It's just I got to cut the original wires.
Yeah, if you've got the correct size coming, then I wouldn't want to cut wires either.
Yeah.
Okay.
Yeah.
I mean, the idea is to saturate the transformer. It can't get more saturated, and I don't think it'll resonate at a different frequency. So, I mean, which one is there any rail that goes straight through? AC? I don't think it does.
No, it would go to a rectifier, but the whole point to having a Ferro is that you don't need a bunch of regulation stages. The only point, or the only time you'd have a regulation stage, is to create a voltage for which you don't have an output tap.
Yeah, but I mean, if the core is saturated, we're not changing the core design. We're not changing the amount of windings, the turns.
No, you're not changing the turns. You're changing the point where it comes into balance. That's what the core saturation does. A Ferro resonant transformer is a tuned RF device.
So Thermal Dragon, I could crimp new connectors onto the wrong form factor cap, but the connectors on the original wires inside of there are exposed. So I could crimp new connectors onto it, but I would also have to, I mean, I guess I could do that. I could slip heat shrink tubing over it.
How far apart are the values? 2 micro?
1 micro. 4 microfarad versus 5 microfarad.
Okay. That might work.
Just remember it's 400 volts, whatever you do.
Yeah, that's kind of why I'm like a little nervous. Like I don't want to have any exposed wires unless they're like very rigidly mounted, which you get with this form factor of stuff. Because that's a lot of voltage on there, and I don't think it's actually 400 volts. I think these are rated up to 450 volts because you might be running because the you can rewire it for 220 or 120 or 240 or 120, I think.
I mean,
Yeah, your rating would be
expect 2x.
Yeah.
Well, we wouldn't like, so if I put this in there and we fire it up and I just check the voltages on the front, and if they all look fine, then we're good to go, right?
Yeah,
I think so.
as long as the voltages don't wreck something else while you're checking.
Pull the secondary fuses?
Just send it.
Yeah, we could pop the secondary fuses out, but yeah, I think it'll be all right. I mean,
Yeah.
I think if we would have wrecked something, we would have wrecked it with the other capacitor that was failing while we were using it.
Well, I thought the jury was still out on what did we wreck.
Well, I mean, if it's a dead short, it's like I was racking my brain with this whole problem. And we're just introducing like a slightly shorted turn. I was thinking, are we just shunting all of the magnetic from that transformer straight into that old cap? It's like that's why there was 0 volts at the output.
No, it would have the core would have heated up then. It would have been, glowing hot.
Yeah,
Or
that
the
was
cap
my
was.
second thing.
Something would have melted down.
Thermofuse, but we checked secondary. We checked primary. Primary's okay.
I mean, the caps are rated to like it's 4 microfarad plus or minus like 5 or 6%. That's what the new ones are. The old one might be as much as like plus minus 10%.
No,
Right.
I meant if you shunted out all of the magnetic energy when the cap went, something would have had to have give. You would see something explosively removed from the circuit.
Oh no, I'm talking more about like the range that the cap might be in. I mean, plus or minus 5% is going to get you pretty close to 4.5 to nearly 5 microfarad, right? So the thing's got to be flexible enough.
Yeah, you weren't off by as much as I thought you were off, and also the with the voltages that may be involved, the risk of the wiring going wrong is more than the risk of it just winding up off by a volt or two.
Yeah. All right. We're just gonna send that one.
Yeah, it worked last time.
It's interesting because there's like a little rubber cap that goes over the end of this thing, and that was already pulled all the way off the first time I opened up the power supply, and I remember thinking, that's weird. Maybe that popped off, but I'm actually starting to think that maybe the capacitor was going bad, and they had identified that and just been like, oh, that capacitor's bad. Well, I'm not going to fix this. And that might have been one of the things that decommissioned the system once upon a time. They're like, well, it's ancient anyways. We might as well just get rid of it.
Oh, Lord, I Googled it.
What was the cap that you just installed?
5 microfarad.
What was the original? 4?
4, yeah. And the new one is rated to plus minus 6%, but I checked it on the LCR, and it came out to like almost perfectly 5 microfarad.
Is that is like the smaller one that you have on top there? Is that like physically smaller? Is that one that one's a 4?
That's a 4, yeah. Yeah.
Wait, so you're saying that you blew the cap on your cap?
Here's a guy that would know.
Yeah, there you go. Yeah, tube time. Thought experiment for you that we're about to test out. Ferro resonant power supply that had a 4 microfarad cap in it. We're changing it out with a 5 microfarad cap.
Close enough.
That's what I was saying.
Yeah.
Yeah, I thought they were going from 4 to 6.
Wait, so what happened to the old capacitor? Was it incapacitated?
Yeah. We were using the system, and it just boom, whole thing shuts down, lose all the lights, everything. And we go troubleshooting it pretty rigorously, and ultimately we measure across this cap up here, and it measures at 2 ohms and never builds up. So I put it on the LCR meter, and the LCR meter just thinks it's a resistor.
So that capacitor is leading the resistance.
Yeah, there you go. Man, you are all about those puns tonight.
Oh yeah, always.
Coming out swinging.
That's every night.
All the time. Can't help it.
Yeah.
So did you see anything like visible when you were running it and it did that? So it just went off, like you didn't see smoke, like no other evidence?
No. But I mean, I was on the front of the machine, and this is at the back of the machine, but I didn't see any like magic smoke or anything like that. So.
And your 2 ohm resistor that pretends to be a capacitor, there's like no bulging or any funny business going on?
Looks totally normal. Yeah, I've never had a ferro resonant cap die, so this is a new experience for me.
It's a sealed steel can type cap, so.
Yeah, it's this big guy.
Yeah,
right
I mean,
here.
often when they fail, they'll bulge out or release magic smoke or oil, or actually, if that's the original cap, it's probably got that spicy PCB oil in it.
Yeah, it's probably got the stuff that'll ruin your day, ruin your month.
Well, that'll put the hair on your chest, or rip it right off.
Yeah,
and everywhere else.
Yeah, or give you cancer in your chest. Either way.
Yeah.
All of the above.
Carcinogenic and mutagenic.
It's a cancer.
That's right. That's right. We use cancer around here, not can't, sir. We're all about that can-do attitude.
So what are we looking at here in the front?
That is a rotating drum.
Oh, that reminds me. When everything took a crap last time, the drum stayed running.
Yeah, we figured that out by looking at the schematic. The drum is running off of the AC and separated from the rest of the DC stuff.
So that drum motor is not going through the ferroresonant stabilizing supply. It's just directly off the power coming in.
Just an AC synchronous motor. But they spin it at like 12,000 RPM. So there's like a huge pulley on the bottom of it that really steps the speed up. Because the AC synchronous motor, I think, is spinning at like whatever 1,800 RPM or what they usually spin at. But they've got like a massive wheel on the motor and a tiny little pulley on the drum, so they step it up to like 12,000 RPM. It's pretty wild.
Wait, so you're saying that this thing is quite literally the Mazda Wankel engine of drums?
Sure. Except that you don't get a little buzzer when you hit the red line.
You're running it up to 12 grand. I heard that right? 11 grand.
This one spins up to 12,000. Yeah.
Might be interesting to put a clock label on the drum spindle, and then one of those optical tachometers on it.
Oh, it has one.
All right. Here goes nothing.
The main clock.
I'm a little curious as to what the mass looks like on that drum.
We got lights back.
Oh, all right.
We're at 13.2 on the plus 13 volt rail. Minus 24.1 on the minus 24 volt rail. Plus 18 is a little high at 19, but it was before as well. Plus 35 is at 35.51. Those are all almost dead on exact what it was before it died the first time. I'd say all of our voltage rails are okay.
Yeah, they look at
turbines. When the turbine hits 70%, flip the igniters on.
Exactly. Yeah, the sound doesn't come through all that well on Discord, but hopefully on the Twitch stream it's high quality.
It's not high quality. It's a little noisy, actually. It's a little scratchy today. Hopefully the bearings will loosen up here in a minute.
So you're telling me that you're going to have an entire ASMR episode of just the Lytton drum spinning up?
There we go. Let me get a picture of that. All right, here's where I need some help. Now that we got the machine up, what do we do?
So one quick thing, I did was Googling this a little bit. It sounds like the worst that could happen is the transformer might get a little bit warmer, so just keep an eye out for that if it actually does. I kind of doubt it will, though.
Okay. Computer lover, that large metal can thing is the rotating drum memory. Yeah.
So if you're wondering about what to do, I think at this point we set it to permanent press, throw a load in there, and see how it goes.
Today on How to Adult with Usagi Electric.
We're instead going to try to get OPUS out. And
You could go through the procedure to run OPUS. I don't have the 1200 manual open, but do you, Roy?
I mean,
I'm just going to pretend it's a Maytag from the 70s because the buttons and the knob look, you can do it.
I slid it over
oddly
there.
enough, like a washing machine, that dial shouldn't ever be turned anti-clockwise.
That's correct.
Wait, why would you never turn a dial anti-clockwise on a washing machine? Oh, yeah, I guess so, because they're like actual physical timers. I suppose it doesn't matter on the new ones that are all digital.
So funny story, the new ones are also mechanical because it turns out it saves them about 1/10 of a cent.
All right.
I mean, most of them have like an encoder now. That's typically what it is nowadays, rather than like a cam timer.
There are new washers and dryers being sold with cam timers. I hate to break it to you.
If we're gonna try and get OPUS off of something, does that mean that I need the scope on one of the PCBs?
Oh yeah, the D1.
So that means I need to open up the PCBs then.
Yeah.
Well, I mean,
if we
it's
can
running
get
now. Let's try it.
Well, hang on a sec.
if we can get Z1, Z2, Z3, and the output of the amp, we should be able to capture everything.
I didn't hear a good sound there just now.
That thing's changing noises a lot.
That doesn't sound good.
It actually got louder and then got quieter. I think
you might have had a head crash.
Nah, I don't think. If I had a head crash, I think it would just continually get louder. I
think it's the bearings?
Yeah, I think the bearings. I mean, the bearings have been noisy and squeaky since day one. We can check if I do halt, ready, run. It executed a couple of instructions, so that tells me that it's still reading something. Oh, that time it halted and it ended up. That's an interesting. Yeah, there it goes. So if I go halt and we step through, that should be reading certain instructions. Oh, and I need to, yeah, we got to spin it down. I need to get the back off so we can get into the actual mode on the toggle switches up here.
Oh yeah. We need to get dev mode.
Yeah. Well, we know that our DC is back at the very least.
Seems like all of it.
Yeah, the voltage level seemed fine, so we're not going to hurt anything. Well, we're not going to hurt anything logic-wise. We could still very well hurt something power supply-wise, but we'll burn that bridge when we get to it.
There's a trick that works with some old hard drives that have bearing problems is you flip them over so that the oil that's like exited the bearings over time can like drip back into them slowly. I think in this case that might be a little difficult.
Yeah, yeah. We also have a problem of like not having enough wire length on the wires to get to the PCBs that they plug into.
Just wanted to insert my 2 cents here, and I'll back out, but it's hard to hear over the Discord, but it sounds suspiciously to me like you might have a malformed ball in one of those bearings.
Probably.
It's very much sounds like it sat for a while and got vibrated or something.
Yeah.
Yeah, as those
Hopefully
bearings
it'll-
get older in age, sometimes they drop a ball. It's natural. It happens.
It's just part of the, growing up.
Yeah.
Yeah. Unfortunately, I can't get to the bearings without taking the entire drum completely apart. At which point we've got all sorts of problems. Other problems that we have to try and tackle. So the goal is, or the hope is, that the malformed bearing will reform itself over time.
Slightly smaller, but round.
Yeah. As long as it shuts up, that's all I care about.
And so right here we have a brand new Keysight oscilloscope.
Sitting on top of a...
Proud sponsor of the channel.
That's right.
Just talk about some of its features. We got 4 channels here, 16 digital channels.
It was wild, man. I asked that dude, I was like, do I, I'm happy to do a shout out or anything like that. He's like, nah, man, all you got to do is whenever you show it on camera, just zoom out enough to see the Keysight logo. That was it. That was the only stipulation for them sending me a $20,000 scope.
You're not even joking about that being a $20,000 oscilloscope.
No, it's actually $21,000. I looked it up.
Yeah.
Like, it showed up and I pulled it out and I was like, this looks like a really nice 4-channel scope. And so I immediately Googled it, and then I sent a message back and I was like, are you sure this is right? And they never replied. So either it wasn't right or they just don't care. All right, so I've got, I need a power cord for the scope.
They heard something about a tube Tektronix scope, some story, and they wanted to thank you.
Yeah, yeah. Hey man, that Tektronix, tearing that Tektronix scope apart is what got me into vacuum tubes in the first place. So its death was not in vain.
They're just happy they don't need to do service.
Yeah. Oh, I got to get the back off before I forget. Spin this thing
Those
up again.
really ancient tech scopes are actually pretty repairable. They actually come with their own solder.
Yeah, because you have to use
terminal strips that are silver plated.
solder.
Yeah, exactly.
What a pain in the butt.
So they got a little coil of silver solder on the inside of the oscilloscope. It's something else.
I mean, they're lucky they don't need to do service. I don't think the technician wants to work on that generation.
Yeah, I bet they got a couple of folks that still know how those things work.
Now I'm wondering if you could put a CVT on that drum.
Get lots of spin up torque and then bring it up to speed.
Get Nissan as a sponsor.
Oh no, then it would absolutely guarantee to crash. Nissan makes the worst CVTs on the planet.
Oh no.
I still think it looks like a washer.
I like Nissan, man. Like, I think, Nissan made some like very cool cars. I think the new 400Z is pretty neat. But boy, do they make some garbage CVTs.
Well, it's just instead of servicing the CVT every 75,000 miles,
you just replace
service it every 15,000 miles, and that'll keep it running.
Yeah.
Just
all right. So we got the back open with the toggle switch now clear. There's a little toggle switch on the back here that as soon as you snap it, as soon as you pop the back off, see if I can get the camera to look at it. So as soon as you pop the back off of the front panel here, there's a little toggle switch right here that puts it into service mode. Which I think is kind of neat.
Yeah. Almost looks like an interlock switch. I think I would have disabled that one just by reflex.
Yeah, and the thing is that I don't know if it has to be enabled for like normal operation when you're running programs. Because when it's closed, we don't have nearly like the wheel on the front and none of the buttons on the front work. Only halt and run work. But when you've got the back off and it's open, now the wheel and everything on the front works. All right, so I think Reese Weatherly.
Hello, I'm here.
Oh, you're here. All right, you had a plan, right?
Yeah, I just posted a possible instruction to the chat just before that we can circulate instructions. Just read the last word of memory, which is the reset vector, and hopefully that will force the track selector onto the last track, and then we can just see it on the scope. That's the theory.
Where should I plug the scope in for that?
I put an image for that.
Okay. As soon as Linux here gets done updating, or Discord updating on my Linux laptop here, I'll pull that up. I don't want to touch the streaming laptop because if I look at it sideways, it crashes. Like I tried alt-tabbing once on the streaming laptop, and immediately Twitch was like, no, I don't like that.
I think that almost crashed Discord at the same time. That time was nuts.
At the very least, we'll need it hooked up to Z1, Z2, Z3 as well, like last time, and then the extra one that Roy has found.
Wait, God, what are you doing? Huh? This is stupid. Let's try that again.
Yeah, I actually found posts that were done just for probing the drum.
So do we need one probe or multiple probes?
We need to record Z1, Z2, and Z3 with 3 channels, and we're going to probe L40, which is actually the general storage.
Okay.
So because we need to correlate the sector addresses with the actual signal, so we can see which bit belongs in which block.
Gotcha.
OPUS is on 2 tracks, guys.
I don't know how we're going to get it from the scope into something like meaningful off of the scope, though. Like, do you guys have a plan for that?
Just record the waveform.
Yeah, if you record the waveform as CSV, we can write a Python script to pull it out.
Yep. Might need a USB stick.
Yeah, I might have to jog inside for that. I don't think I have a USB stick out here.
You don't have a Saley type thing, do you?
I do, somewhere. I wish they would have unlocked the digital thing. Or they're supposed to send you a piece of paper to unlock the digital thing on this, but I didn't get that paper, or it got lost in the packaging material or something. You're
lucky it's not a Tektronix, where I think you need a physical module that just has a small ROM on it.
That's old. That's the old ones.
Yeah.
That got us starting to be sued, that article.
All right. So you've got a picture here. We want Z1, Z2, Z3. And I'm going to get that on... Okay, I see you've marked what Z1, Z2, Z3 is, but there's like a lot of things that I can clip on there. I need to pull up the actual schematic.
I mean, there should be like physical pins. At least they look like physical pins. Like probe points.
That say Z1, Z2, Z3?
Literally, I noticed that they put literal labels next to them.
Oh, yeah, I got them. Well, not Z1. I've got Z2S, Z3S, and then L90S.
Yeah, Z1 is a bit higher up. It's on the right side.
I got you. It's next to the black diode there.
Yeah.
I got it.
Oh,
all right.
They also have not Z1, but I mean, I can guess what's in there.
All right, let's go green next. Green's gonna be Z2. I hope that's an acceptable ground. We'll find out when I spin it up, I guess. Blue is going to be Z3. All right. What's the last probe going up to?
It's on the far left. I think it's marked L40 on the board. There should be another pin.
I've got an L. Yep, L40. There it is. All right. Well,
What's L40S?
I put the extra S because L40 is technically the one that's one bit shift after the shift register. And like Z2 and Z3, they put an S next to it, so I'm just gonna copy that.
it's 10x, 10x,
Gotcha.
10x, 10x. Okay. All right. Let's get our scope on here.
I'm also happy I found what that black block is on that board.
The 100 nanoseconds delay line?
Yeah. It's like,
All right, well.
it's tiny in the schematic.
If we want to record this to a USB stick, I should look for a USB stick.
Except if you can like plug it into like directly to computer. I don't even know if that would work. Normally I just dump everything to a USB stick.
Yeah,
I'm pretty sure that Keysight has software if you're going to plug it into a computer.
Well, Keysight has software to view recorded shots, but I haven't figured out a way to record, because we were doing this with the UE1. I didn't find a way to record the whole dang thing unless I zoomed way out, and then you lose the resolution that you need. But we'll fiddle with it. But I am going to set you guys down for a second while I run inside and grab a USB memory stick, because I don't want to have a good reading of Opus and no way to record it. So I'll be right back. And I'm not taking the mic with me.
Okay. I mean, Opus is not very long.
It's not really an OS. It's more like a small library.
Small library that's required for the keyboard to work.
Than anything else external.
Well, I mean, it has it. Yeah, it's. I don't know if it functions as a library or because it has like the assembler that is that. So yeah, I don't know. I don't know. Is that actually working as an assembler, or like, is it compiling it, or is it acting as an interpreter? I'm not really sure.
It's just interpreting, but it's coordinating every I/O. So yeah, it has. I mean, it has input and output control, so it is at least a BIOS.
The 1231 manual has a pretty good description of what it is and how to use it. I think we got that from BitSavers, right? It's got to be a link to it in the chat.
Yeah, we got the programming manual also that yes. I should find out who scanned it in, because somebody bought it and scanned it in. And yeah.
Is there a link? Just search programming manual.
It was a Kombucha that had it.
All right, I brought two, so hopefully one of these will work. Y'all are still there, right?
Yep.
Okay.
Yep.
Excellent.
Did I manage to paste it in?
Let me see what's on these things.
Just sitting here admiring the 1144 with the FPS 100 and 3000.
It looks really good. It's a shame that there's nothing behind this. We'll get there. Where's my USB stick at, man? I just plugged it in. I'm in our file system. No.
Oh, I didn't copy it correctly. Great.
Wait. How come? I guess Linux doesn't want to see that one. There we go. All right, that one works. 73 gigs free. So that should be good on this guy here. Unsupported USB device detected.
Yeah, sometimes I don't like the big ones. You might have to, do you have one which is like 16 gigs or less?
Oh, I may not have just gotten it in all the way. Hang on a sec. Let's see here. Well, you guys are just like looking at a big old logo. I forgot that the camera was super far away. All right. Unsupported USB device detected. Great. Oh, okay. All right. How about you? Are you supported?
Scopes are usually really picky about the file system too.
I mean, I don't mind formatting one of these. That one looks like it's... well, the light's on and it hasn't said anything, hasn't screamed about it yet. Let's do save recall. Set file name. Okay. But I can't. This action is not available in this mode. Oh, I guess I got to take a single shot. Or not. Like...
If it's stopped, it should be able to record now.
Yeah, it should, but it's not. It doesn't want to. Save to. Please insert a USB storage device. Just does not detect it. Did I?
You know how it's formatted?
I have no idea how it's formatted. USB device installed as USB. So that one is actually detected. Unsupported USB device detected. What? What do you want from me, man? Save. Saving to file scope 0. File saved successfully. All right, let me pull it out. Let me see if I can find that file on here. Scope0.png. Yeah, that's saved. Okay.
Oh, but that's a PNG. Well, I mean, a scope trace would...
Yeah,
if it's able to make a PNG, it's able to do a CSV.
Yeah, I was just trying to see if it could read the dang floppy or the dang USB stick, and it seems like it can. Okay, so we're going to go back to run here.
I put some instructions in the chat earlier about from Keysight as to how to change to CSV mode when we get to that.
Okay.
Oh, do they save in proprietary instead? It's like fun.
Yeah,
the online says CSV, so I suppose we'll find out.
Yeah, I think Keysight doesn't do CSV if you want the whole trace.
Boo.
All right. So when it spins up now, we should see stuff on the scope here. I'm going to try and to get this so you guys can see both the scope and the front panel back there, but you can't quite see the full front panel. Okay.
Yeah, so we just need to capture about 5.12 milliseconds.
I'd probably capture like 2 or 3 times drum revolutions, so about 15 milliseconds. Because if we miss the first sector, then it's a pain in the neck.
Yeah. Try to capture a few drum revolutions at least.
Yeah. I mean that's the length of our program.
Let's make sure that we know what we're doing first here.
Yep.
That's what a single shot looks like right now. You guys can't really see much of that, but we'll come back to that. We're triggering off of Z1. I believe we're up to speed. So what's my order of operations here?
Okay, so on the front panel, if you can halt it, and then we need to enter an instruction into the control register and the instruction registers.
Okay.
Start with control. And so in that, you want to have 8F. So, yeah. 1000FF.
Wait, I don't have a control register. I've got instruction and accumulator up here.
Well, you've got control is the command register. So when it's on that, it's modifying the command register.
Oh, okay, so I want to do 8F. What'd you say, 8F?
Yes.
Okay, so 10001111. Okay.
And then shift to instruction 32.
Okay.
And then put in all Fs, so all ones on that one.
Currently is.
FF.
Yep.
Good. Switch to the next one, and then you want another 8F.
Another 8F.
So switch.
Okay. 8.
Yeah, so in 24.
Okay. I've got that in there. Then to 16.
Yep. FF again. So we're repeating 8F, FF, 8F, FF.
Okay. And then 8 is going to be 8F.
Yep.
And then 0 is going to be FF.
Correct.
Okay, and then I'm back up to control, which is at 8F.
Yep. So leave it at the bottom, point down control, leave it at that, and hit the run button. Don't hit ready, but hit run. Because ready will reset all that. So is it just running continuously, or did it halt?
I mean, none of the lights are flashing, but it says run.
Okay, so I think it's circulating that instruction. What do we got on the scope at the moment? What's it doing?
I mean, the track light's on, and I was seeing the track being selected while we were doing this. It was hilarious.
Yeah, it was like changing up and doing stuff.
Yeah. So just to make sure that we're actually reading something.
I mean,
that doesn't necessarily look right to me.
Yeah, a bit the same.
Yeah.
The L whatever the 40 that we're on, it just looks like the same repeating pattern. Oh no, we got some other stuff going on there.
I mean, it just doesn't look like. Is it at the same scale?
I mean, I don't know. I don't know what you guys are expecting to see here.
I mean,
he's doing something different, but not sure what.
Are all the tracks on the same scale?
Voltage-wise?
Yeah.
No. The clock tracks are down at like 10 volts per division. And the data track that we're looking at is at 2 volts per division. So.
Okay, at least that makes it a bit better. It's like
one thing, could you halt the machine and then let's have a look at what's in the accumulator?
Yeah. So there's a halt. Put that back to run. The accumulator is
just read it out for me.
Bearing suddenly got quieter. So 32 on the accumulator is 00. 24 is E7. 16 is FF. 8 is 10. 0 is 08.
Okay, so that E7FF that's in there, that's a jump instruction. That's jumping over into 7FF, which is the track 15/16 rather than... I'm just wondering whether Opus is not actually on the last track. It's actually over on track 15/16 instead.
Oh, Opus is on 2 tracks.
Yeah, it's on 2 tracks, but they call it track 16, but I would call it 15. So, and I saw this in the dump from a couple of weeks ago that when you dump some instructions, that it seemed to be jumping over to 7FFF. So yeah, maybe Opus is not on the track, because we did see some data on the scope, but we didn't see a lot. So I'm wondering whether the only thing that's on that last track is a jump to somewhere else. Could we maybe switch over to the other track and just see if we get more data off that?
Sure. Tell me how to do it.
Okay, I'll just figure it out here. It would be this time.
It's 8F, but 7F for the instead of FF.
You got to be way more descriptive than that. So
I'll do it right. So we want 87FF so 87 and FF repeating this time
instead of 8F 87.
So yeah, exactly.
Okay, gotcha. So we go
because that's where it's.
Control is going to become 87.
Yep.
32 stays FF. 24 becomes 87.
Yep.
16 is FF. 8 becomes 87. 0 is FF. We're back around to control. And then just hit run again, right?
Correct.
Scope doesn't look all that different, but let me grab a single shot here. Oh, we definitely have data. That definitely looks like data. We've got zeros and ones going on.
You just jumped to track 15 instead of 31.
Yeah, so the question is this actually a 2048 or 4086 sector drum? If it's 2048...
It's a 4000. It's a 4632. Is the literal number written on the side of it?
I mean, it has the extra bits. It has the extra chip. It's not a 1602. It's a 1601. So it has the 4000. So it has track 31 and 32.
Anyway, but that's looking much more like code to me.
Yeah, this is much closer to data.
Given that the technical manual is wrong about other things, like saying it's ASCII when it's clearly not, maybe it's wrong about where Opus is as well.
I mean, I can take multiple shots here. We can grab as many tracks as we want. This seems to work.
Yeah.
Now the question is like, how do I save this in a way that you guys can make sense of it, right?
How long is the trace there that you've captured there? Is that like 20, 30 milliseconds or so? Or how long is the total?
I got about 600.
Look at the track at the bottom.
I got about
only like.
Hey, Roy, let me talk. I got about 600 microseconds.
Okay, so we need to get about 15 to 20 milliseconds worth of data, so we can get like several drum revolutions.
Okay, that's going to be.
Each drum revolution is about 5.12 milliseconds or something.
How about 10 milliseconds?
We can start with that.
Okay. It just looks like a blur. Now let's try saving this. Save our format. What do y'all want it as a CSV?
If you can get it, yeah.
All right, let's try that. We'll do CSV. I can do CSV data or ASCII XY data, which is also saved as a star.csv. We'll start with just regular CSV.
I think so.
If that doesn't work, then we'll do... what name should we name this one so we know what we're looking at here? This is track...
We're track 15. with 0 index numbers.
Okay, so I'm just going to save it as track 15 as a CSV. We're going to save that. File save successfully. And then I'm going to dump that in the Friday Night Lytton. And y'all can see if you can make any sense of that. See if that's something that is readable and works. I don't know what you can do with that amount of CSV data. I don't know if that's going to give you anything that's understandable even. Because we're zoomed so far out that I don't know how it's going to save. I don't think you're going to get the resolution that you need.
Oh, we should. This is a mega sample scope or more. I mean,
yeah, but I don't think
need.
I don't know how it saves that though. There might be some Keysight proprietary stuff going on because that doesn't look like enough data.
Yeah, MX Shift on the Discord is saying that you need ASCII XY to export 1,000 data points, so maybe try exporting with that as well.
Okay, we'll try that.
I'm just trying to load it up in LibreOffice here, the CSV, to see if it looks like reasonable data.
We'll track 15 ASCII-XY. Okay. And we're going to put that as ASCII XY data. And then I'm going to save it. And I tell you what, I'm just going to save it as a binary data file as well.
Yeah, maybe we can parse that.
I'm just going to throw a whole lot of spaghetti at the wall, and you guys can tell me which one stuck. I also have frequency response out. I've got so many more CSV styles. Arbitrary waveform data and analysis results. And reference waveform data. Let's try arbitrary waveform data. Oh, that just puts it in a folder. And save to file. I don't know what you're doing. Okay. Press to save. That action's not available in this mode. Doesn't like the arbitrary waveform data, apparently. Okay. Let's do a reference waveform file. Save to USB. File name. Wait, hang on. What is that? Ref. Drum sounds good now. The bearings finally shut up. All right, let's do multi-channel waveform data. Say that one's a ref 1.
Oh yeah, that original CSV only has like 2 kilopoints.
Yeah, I didn't think you guys were gonna get much off of that when I was looking at it. All right, let's.
Yeah, it's not really given a very good square waves on the data. When I look at it in LibreOffice.
All right.
I mean, the program itself should have at least 5,000 points, and that's if you capture just 1 bit per bit.
Dave, if you you know how to set the trace depth or the horizontal on that scope? I actually don't. I know on the Tektronix, but it's a little different.
What do you mean?
There are modes where you cannot fill the whole buffer. Essentially, you have a RAM buffer that you're filling whenever you trigger. So it may not be using the whole buffer. And usually that setting is in the horizontal menu of the scope. But is anybody here an Agilent or Keysight person?
I don't know, but it's saying 156 megasamples per second or something.
MX Shift is typing.
Yeah, so I posted the XY, the ASCII XY gives you a separate CSV per axis, per channel, essentially. Go into setting menu and select the number of points to save. See the link you posted earlier. All right, hang on a sec. Let's go back to save/recall. Save format XY settings. Oh, length. There we go. So if I've got 10 milliseconds, what should my length be?
10,000 points or more.
It would help if we had something a little more specific.
How many could you do? As many as possible.
All right. Well, I'm like, I need some help at least. Like, throw me a ballpark number. 20,000? 30,000?
Let's put 20. It's like, let's see if that gives us something.
All right, that's going to be times 10 to the 4. Oh, there we go. There's a max. Max is going to be 1, 2, 3, 2 million. How about 2 million?
Oh, fun.
You got it.
I like that number.
All right.
We're gonna downsample it.
ASCII XY. Let's change our file name to track 15 ASC XY. Okay. Why that selection is not available in this mode? Oh, I gotta. Oh, because the USB is like plugged into the computer, not plugged into the scope. Save to USB. File name is track 15 ASC XY1. Settings is length is, I swear that says 2 million. So press to save. Oh, this is going to take a minute. This is going to take a minute.
You're going to want to zip that up before you send it. It's okay.
Yeah.
This is going to take more than a minute.
We might want to just...
Yeah, let's cancel this.
10x.
Yeah,
2 million. 2 million might be too many.
Yeah.
I'm just doing some math here to try to figure out how many is reasonable for a good sampling.
10x on top of...
Yeah, I'm going to cancel this. Action canceled. I'm going to change the length to... let's do 100,000. So let's go 1, 0, 0, 0, 0, 0.
Hang on, before you guys get too far off track, you know the drum RPM, and you know the meg sample rate that's selected. So take the drum RPM, divide by 60 to get revolutions per second, and then, you know, from that, then you know how many samples you need to cover one rotation, and just take, you know, like at least 4 or 5 rotations and look for the repeating pattern.
Oh yeah, the drum repeats every 5 milliseconds, give or take 0.1 millisecond.
All right, 100,000 is a lot faster. We can go up in resolution if 100,000 is inadequate.
My test file that I built was based on 100 nanoseconds intervals, so
I don't know what that means in terms of changing it to the depth. I'm not good at math, remember?
yeah, it would be like, what, 10 megasamples? So yeah, 10. Oh no, I might be out. What? No, I'm orders of magnitude out here.
All right, this is going to be the 100K CSV. 10 megabytes of CSV.
Wonderful.
There you go. That should have a lot more resolution. Take these up to here. We're going to get rid of those. Take these two. We're going to get rid of that. We're going to close you. I'm going to pop you out, put you back into here.
I mean, we don't know if the other format that puts everything in the same file can do that many output. Somebody was asking for why was it a file per track?
Well, yeah, the XY sets it up like that. The ASCII XY, no matter what resolution we go at, it seems to go at the one file per trace.
We should be able to do some join on the two of them as long as the seconds counters are the same.
All right, so far does the yeah, it says Val's just saying that the timestamps aren't the same on those four, but I don't know, maybe y'all can make it work.
It's looking reasonable when I try to plot it. So we're going to have to write a lot of scripts to try to get the data out of this.
Hey, I got a stupid question.
Shoot.
If you do the math functions on the threshold, could we just convert the analog data to digital on the scope?
We could, but we wouldn't know where data starts or stops at. So, like,
well, the threshold thing will make the it just whenever it passes a certain voltage level, the clock and the others and the data ones. I'm just trying to thinking if we wanted to square up the edges to make the CSVs a little smaller.
Yeah, I really find it weird that we're not just seeing square waves, because we should be seeing something similar to Z1 and Z2 and Z3 for L20, and it's like, why isn't it?
Yeah, I was about to ask that earlier. It's
that
like
definitely
a weird
looks
tri-level signal.
Yeah, it almost looks like we're looking at transitions, it feels like. Magnetic transitions or something like that.
Yeah, because I know that L40 is before the delay line, but it's like just hard to tell. Because it's post a comparator. It should be digital, essentially.
If it were magnetic flux at this time scale, would the pulses be any shorter, do you think?
I don't know.
I mean,
I need AJ here.
I saw what they were expecting, and
yeah, Meltdown. The logic analyzer function of the scope is not unlocked, so we can't use it. I have the thing that plugs into it, but it never told me none of the stuff. I never got the piece of paper that told you what code to punch in to unlock it, which is unfortunate. But we shouldn't need it. We should have the 3 clocks here plus the entire data track multiple times over at this scale. I'm just waiting for
stitching together CSVs into one combined file here, and I'll post it in a second.
Yeah.
While you're doing that, would it be? Do you think that 100K is like? First of all, do you think that you've got enough information there to piece together a data file? Do I need to go like? higher with my sampling, lower, well, no sense in going lower, but I can go higher. We're at 100,000. I can, and that's saved in about 30 seconds. I could go up to 200,000 or 300,000 if we need more depth or more precision, rather.
Yeah, I think there's enough in there. I'm
Yeah,
not
I
entirely
think so.
sure, but
It looks like it's going from like negative 5 milliseconds to positive 5 milliseconds in the time column. So we've got 10 milliseconds of data there, and there's 97,000 points. So we're just going to have to analyze it offline and see what we come up with, I think.
something.
Can we also maybe look at track 14 as well and get both of what we think OPUS is, and then we can analyze during the week.
Jump to track 31. So 14 and 31.
Why don't we get them all, man? Let's do like 14, 15, 30, and 31. Get all 4 of those because that's where we think OPUS might be, right?
Absolutely.
So to get to 14, I want to take... Oh, I'm still currently running. So we halt.
So this time you want 877F as the alternate bytes.
Okay, so 87. Well, why is that one at FF? Not. Didn't we change the instruction to be not FF?
Every second one should be FF, so that's fine. You want to change that to 7F though instead.
Okay.
So it'd be 877F, 877F, 877F.
Gotcha. 877F. 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 Back to control, which is at 87. So we hit run. That's definitely got different data on it. I'll take a single shot.
Track lights off. So
this should be track 14?
14.
Yeah. So the track light, it's basically the low bit of the track number. So it's currently 0, whereas 1 before. So we're definitely on a different track.
Okay. We're getting that at 100,000 as well.
Yep.
And then let's bump up to 30 and 31 next.
Yeah, so 30 will be 8F, 7F.
8F, 7F. Okay. So control would be 8F, right?
Yes.
That's where we start. Okay, gotcha. It's still saving track 14. Okay. And if that's at 1 millisecond per vision. If I zoom in, that definitely has some kind of data on it. Okay, let's go back to run. Let's halt to you. Go back up to control here. What was it again? 8F, 7F?
Yes.
So 8F, 7F, 8F, 7F, 8F, 7F, 8F. Okay. Hit run on that. Take a single shot. This is track 30 or 31?
This will be 30.
It's 30.
31.
No, it's 30.
Well, 0 base 30, 31 if you count from 1.
Yeah, well, I'm 0 based. I'm a computer programmer.
Yeah,
all right.
But
That's
legend
saving.
oscillates between the two.
All that matters is that whoever's going to be parsing the file knows what track it is. Because like Lytton has no clue what they're talking about. All right, that's currently saving. The next one will be 31, correct?
Yes, so that'll be back to 8FFF.
8FFF, okay. I mean, this is pretty cool. We're like actively using the machine, which is pretty exciting.
Yeah. I'm happy that it's just circulating the instruction like I thought it would.
So 8F, FF, 8F, FF, 8F, FF, back to 8F, do a run, take a single shot, change our track name to 31. That is now also saving.
And if this works, once we analyze it this week, then we can maybe have a look at the other tracks later, see if there's the last program still running on there.
I mean,
yeah, like, so if you were to write a program, what track would you want it to live at? Like, we can take a look at like the most obvious track here and see if there's any data on it at all, right?
A lot of people
let me just look at the
started
address.
on 300.
Yeah, so 300 hex. I just so yeah, so we should be able to just look at 8300 for that one.
All right, let me drop these in the chat, and then we'll punch that in. This is going to be track 14 at 100,000 samples. And then we have track 30 and 31 at 100,000 samples. Also coming in hot. Uploading 30 megabytes of comma-separated values here. That's a lot of values. All right, what track am I headed for?
Okay, so this time we'll do 8300.
8300. Oh, well, you're not supposed to go counterclockwise, right?
Oof. Yeah.
No.
I mean,
all the way
once
around again.
Once it goes over control, it should time up fine.
Yeah, we're back up to control. So what was it? 8300?
Correct.
Okay, so 3. Took me a second to remember 3 in binary. 00. 8 3 00 8 3 00. Back down to control, which is 8 3. Hit run. I mean, there's definitely some data in there. If I do a single shot, I've got zeros and ones. I think I do, at least. I don't know. So what track is this?
So this is I don't know what that it'd be, like track 6 maybe. This is basically where the OPUS stores the user's program on this track.
Okay.
And there's another track where it stores variable values, so we might dump that one too.
So is the program limited to being a single track?
I think it's 128 words, but I'm not sure whether that's the same as Latin words or it's whatnot. But I think so. It's 128 words, and then there's also 64 words of data area as well.
I think there's like multiple ways of like expanding, because like there's a bunch of tracks.
All right. So what's my next goal here?
Okay, so 8380.
Oh wait,
this
hang
time.
on a sec. Never mind. Let me try that again. I never ran it. It's still sitting on halt.
That might be fine.
Yeah. So let me hit run. Let me take another single shot, and we'll save that one again, overwriting the old files.
The hilarious part is they should be identical.
Oh, whoa! Lights went wonky while we're sitting here running. I've got both halt and run lit up at the same time.
Oof,
Ooh,
something's
oh dear.
weird.
Yeah, this is saving a trace, but this has now stopped. I can't do anything at this point.
Uh-oh.
Something went weird.
I can hit ready, and that clears everything, but I still got halt and run illuminated at the same time. What's our voltages look like, just to double check?
Yeah, something went weird.
Yeah, even the other lights are still kind of illuminated.
We didn't blow up the capacitor again.
Might have. Nope, 13's at 13.2. Negative 24 is at minus 24.08. Plus 18's at 19.5. Plus 35 is at 35.46, so that's all on point. So we didn't lose any voltage rails.
I mean, ready and halt are on one data line, but it's like I don't know why the heck it would be oscillating.
Yeah, I can hit ready, and it illuminates everything, lights up the halt light, but as soon as I let go of ready, it goes back to that weird, like, half halt, half run state.
Yeah, so ready will force FF into this command register, so this looks like what it's trying to do.
So somehow,
should we use the magic one, just turning it off and on again?
yeah. Well, I don't think there's any way we can get out of it at this point. But I did get a scope shot of track 6 before it went wonky, so I can drop that in. Yeah, I have no idea what happened. Something got hot, probably.
That or you hit some temporary state while you guys were monkeying around with instructions.
Boy, the drum gets warm.
Those circuit cards laying flat may not cool as well as when they're vertical.
Yeah, I'm gonna go get a. I bet you we got hot because I'm starting to sweat as well, which means that my AC is probably not keeping up very well. I'm gonna put a fan on it.
I mean, the thing draws what, 500 watts? How much of that turns into heat?
Probably all of it, given how unpowerful the thing is.
It might help to put small blocks between the cards to give them some space and then blow the fan.
Yeah.
We're just gonna get some air moving across it here. That'll probably make a huge difference.
Yeah, but I was just thinking that the lower cards are going to be blocked from the fan unless there's a little bit of space between them to let the fan blow between them.
There's about 2 fingers width worth of space between the cards with the way that they're sitting.
Okay.
Yeah, that's gonna move some air across stuff. I mean, I've got all the sides off the machine as well, so it's not going to be like funneling air in ways that it intended.
Yeah, but with the cards normally vertical in operation, that lets convection do a bit more work.
Did you say the drum was getting hot?
Yeah, the drum was getting warm.
The drum itself or the motor?
The drum itself. I mean, there's bearings in the drum, and it's spinning fast. It gets warm. So does the one on the G15.
Okay. No, I was worried more that the bearings were getting excessively hot.
No, they're not like burn your hand hot. It's warm. I can like hold my hand on it for a while and it's okay. Get some air flowing across this thing.
You can see that it was designed with, aluminum ribs in the casting for some heat sink. So
yeah. Yeah,
Yeah, that's true.
This should help keep the drum cooler as well. There's going to be some air moving across it. I mean, I can feel the air on the other side of the machine as well, so there is air moving through the inside of it now. All right, let's spin it back up, see what happens. Well, it's halted. That's good.
Yeah, that woke the scope right up.
Yeah. Oh, we're back into that half halted, half running mode again. That's weird. So did we have a like a chip fail or something?
Or one of those connectors.
So like it was halted until the drum got up to speed. And so it was halted in FF. When the drum got up to speed, it dropped into this like half on, half off mode. I'll post a picture of it.
Oh, so the second it comes out of the warm-up period, it just goes weird.
Yeah, and you can kind of see it. The track light and 765, 321, and 0 maybe are kind of like partially illuminated. Halt and run, the halt and run buttons don't do anything. K equals 0, K equals 1 does set that light on and off. Ready puts us into halt. If I push and hold ready, we're back to where we were. Pushes into halt and turns everything to FF. And I can see that changes stuff.
Just trying to halt and run constantly, running alternate instructions or something. It's just...
Wait a minute. Okay, I just had a stupid thought. Check and make sure none of your probes have moved. That they're not touching something they shouldn't, anything like that.
Well, I'll tell you what, why don't we just pull all the probes off completely?
Yeah, that might.
I mean, we got the tracks that we wanted to get, right? At 100,000 samples. We should be pretty solid with the scope work. And if we didn't get what we needed to get, we won't know until we analyze what we've got, right?
Yeah.
So I think we're safe to pull the scope away for the moment.
Are you sure that it's not showing one of the errors that are built into it? I'm trying to see what the light pattern is for that.
The only errors for the front panel require OPUS to be valid. Their software.
We don't know that it's not.
I don't think we were executing OPUS.
Choose back in place here. I mean, we could have lost. Like, there's about 1,000,001 things that could have died here.
Yeah, I know. I'm just trying to think of low-hanging fruit.
Does this machine store the accumulator and the instruction on the drum, or is it in static logic?
They are in perpetually rotating flip-flops, matching the drum.
So physical shift registers, basically.
Yep. 6 chips.
Man, nothing feels hot at all. Everything is nice and cool.
No, nobody saw any magic smoke or smelled anything, I assume.
No. It didn't even make a funny noise. It just stopped. Just suddenly changed.
I mean, it's like the first time. It's like...
Yeah, that's why I'm hoping it might be just something physical, like when you were pushing buttons maybe you bumped the machine a little bit and the probe shifted and shorted something adjacent. Hopefully it's something easy like that. Now don't trip over your fan.
Yeah, I'm trying to get it over. Now that I got the cards vertical, I'm trying to get the fan over to this side. Otherwise, the fan is just going to be hitting the backside of one card completely, and it's never going to make it over to the drum itself.
I mean, my only thought is that either you lost a register or something, or there's something wrong with the whatever this machine uses for sequencing, like some kind of timing issue.
If we lost like the sequencing, it would be. I don't really know where the sequencer lives. I just know it's diagrammed.
All right.
I mean, the whole machine runs on like a 4x4 grid of sequence numbers.
All right, let's see if it does the same thing again. Just coming up. Drum's coming up to speed. We're still at FF. Track is on. K1 is on. We're halted. We're still halted.
Oh, that's cool.
Well, we lost all the lights on the front, but we don't have halt and run illuminated at the same time. Ready doesn't seem to do anything. Halt doesn't do anything. I can't set any lights, so we're actually worse off than we were.
That smells like connector then.
Yeah.
Because we moved the boards.
Halt, run, ready doesn't do anything. K1, K0 doesn't do anything. None of the buttons do anything.
Switch on the back is still out.
Yeah, if I push it in, nothing changes. That doesn't do anything.
Yeah, I think it only mattered on initial power up anyway.
Yeah.
So
when you move the knob, do the lights over the knob change?
No, nothing changes. The only light
ones are directly connected to the knob, so it wouldn't matter.
Yeah, I was thinking maybe did we lose a bulb bias voltage or something like that? Because those are directly off the. Oh, the AI 2097 says that the lights over the knob did change.
Oh, did they?
Okay, so we didn't lose a bias voltage or something silly like that.
Well, no, because all the lights come on when it first turns on.
Yeah, but the lights could be pulled down. If the bias goes away, they won't pull down. And wasn't the ready light burned out?
Well, we don't have ready and power. We don't have either of those lights. This is making me wonder if, as one of these connectors got hot up top here, they started to lose connection.
I mean, in my mind, it's either that or a solder joint. I'd rather it be the connector.
Yeah.
No, you don't. Where this coming? The connectors on this machine, you don't want it to be a connector.
Yeah.
I would wish for a solder joint.
Well, it doesn't matter what it is. It's going to be a nightmare to try and troubleshoot. Let's just kind of shuffle things around a little bit here. I mean, unless we had a crash and lost all the data on the drum.
I'd assume we would hear that.
Yeah.
Yeah, I would hope so too. It's all sealed up pretty well, though.
Oddly enough, for everything that's pretty much connected to the front panel doesn't touch the drum.
Yeah, but it could be that there's, you know, the reason it doesn't show anything on the front panel is because, you know, it can't load anything off of the drum. So it's just like, yeah, you're just getting all zeros, man.
Yeah, but like the set and reset of everything are flip-flops. The I register and the A register, so the instruction and accumulator are all flip-flops. So, and pretty much all of the sequencing logic is like just gates. It's like we would have lost a clock, but we didn't see a lost clock on the scope.
If we lost 5 volts, would that play into what we're seeing here? Because 5 volts is not checkable on the front.
If you lose 5 volts, you lose pretty much all your logic, so yes.
All right, let me check that. I can check that on an actual chip, I think. These chips are the same as like 74LS stuff where they've got 5 volts on pin 14 or 16, right?
Yeah.
Pretty much.
Okay.
I just posted stitched together versions of all the track files onto the chatters.
Okay.
So they can be used for analysis.
Great.
All right. Well, this time we got halt and no lights. That's not a good start. Well, we lost something.
Halt still requires 5 volts logic, I think. Or if it has no signal, maybe it just defaults to that.
Yeah, ready doesn't do anything. Run, K1, K0. They don't do anything. Reset. Yeah, the instruction light does light up and the accumulator light does light up, but nothing else. Let's check an IC here. And we're sure that the ICs definitely have 5 volts in the same place as the 74LS.
Yes.
Because I got 1.1 volts.
Well, there's your problem.
Yeah, so it definitely sounds like we lost 5 volts. Let me check our front panel voltage, our front voltages here. Make sure that we're still fine on the big ones here. Oh, no. Our plus 13 is actually a little high at plus 14.
Oh, it might be unloaded due to the 5 volts being derived from it.
Minus 24 is still on point. Plus 18 is still at plus 19. Plus 35 is at plus 36. Yeah, I think since we lost our 5 volts, the whole power supply is kind of unloaded right now.
Is there a separate fuse for 5 volts?
There's a whole separate circuit for 5 volts.
Remember that had that? We had all that, those transistors that were set up to kill 5 volts. Maybe that came into play now.
Yep. Yeah, because I am showing. Let's see if I can find. So you're ground. There you go. Are you 5 volts? I'm pretty sure you're my 5 volt rail. Yeah, so I'm checking on board C here. And 5 volts is showing 1.093.
Sounds a lot of percent off.
Yeah.
Yeah, 1.0 sounds like it's either shunted to ground through like a transistor or something, or you've got like a partial short.
If you had a partial short, there'd be smoke.
Yeah, same on board B. I can't check board A. I can check board D though.
I'm pretty sure technically 5 volts is the wide pins on P1 on the card edge.
Oh, you're talking way up there? Yeah. Yeah, so now we got to figure out where 5 volts is generated at.
And luckily for us, I know it's in the manual, but unlucky for us, it's pretty much somewhere.
Yeah. I think it might be on that extra little board that swings out, but let me double check. I need to take a look at what the 5 volt rail looks like again. Did I not save that last time?
Okay, that's
what is wrong
12.
with me? Oh, there it is. Technical reference manual. All right. Do you know what page the 5 volt schematic is on? It's got to be around here somewhere.
Trying with the keyword +5.
348. Page 348. That's where the +5 volt regulator's at. Has some remote sense stuff going on. It takes +13 and +35 volts and gives us a regulated 5 volt out via Q99 and Q118. And that says it's on board N. So where is board N?
I think it's in the power supply.
That would be a solid guess. What board are you? Well, I can't. For the life of me, I can't figure out what this swing out board does. But I don't think it's our 5 volt rail.
Yeah, the swing out board is board F, I think.
It's not marked on it what board it is, or at least not that I can see. I'm gonna get these guys out of the way before I kick them. All right, so we thought we had our power supply problem solved. We do not.
Well, we did. We just developed a new one.
That's right. Yeah.
Oh, on the positive side, board N is, I think, the top board of the power supply.
Yeah, that makes sense. Oh. Oh, all right. I can see a very exploded fuse.
That might be the 5 volt one. Or
Well, that would be a solid guess. See if I can get it out.
actually don't see fusing on the 5 volt on the sub schematic for its regulation.
Yeah, I think this is.
What fuse number is that?
I don't know yet. F4 it looks like. No, maybe. Yeah, F4. F4 is a solid guess.
So that's your plus 13 volt rail.
So why was I seeing a good plus 13 volts on the front then?
Because the probe points before the fuse.
Surely they didn't do that.
Oh, they did. J7 is before the fuse.
They absolutely did. Those jerkwads.
Seriously?
Wait, That means you can check your voltage when you remove the fuses.
Yeah. Yeah, you can have all 4 fuses out and still check your voltages.
Probably so you could isolate the load.
Yeah, that fuse definitely went down.
It might have just been worn out.
At least this is a standard AGC fuse and not one of those bus fuses with the integral cap, right?
Yeah, I can replace this, and we'll see if it pops again.
Yeah,
That's kind of my modus operandi whenever I have a bad fuse is just replace it. And if it blows again, then you've got a problem. And if it doesn't blow again, then it's likely that the fuse was just 50 years old.
Managed to find those capped fuse for like $10 on DigiKey.
What are you? 4 amps. Wow. Okay.
I mean, does it look like it blew hard, or was it like kind of a slow burn?
I just posted a picture in the Friday Night Litten. You should be able to see it. It looks like it blew.
Yeah.
Yep.
Safety.
Yeah. That's right,
so
Tanella. Safety is overrated. Safety third. That's how we roll around here.
No, you got any 22 shells?
Yeah, I don't have.
That'll fit.
Yeah, I've got a 3 amp and a 5 amp. That's not great. Oh, I've got a 1 amp and a 5 amp in this size. Let's see what else I got over here. Those are slow blows. We don't particularly want slow blows. Well, that's not great. I don't particularly want to put a 5 amp in a 4 amp spot.
Oh, stream crash for me.
Did the stream die?
Looks fine.
Maybe it was just on my end that I was being stupid.
Oh. Now it's good. It was hard pixelated.
Yeah, it's still going. Whoa, hype train's incoming. Heck yeah. I don't know where that came from, but thank you guys. You have a limited time. I don't know what that means. Stream's fine. All right. Safety third is an actual philosophy.
And if it's
yeah, all right, Commodore Z, that makes sense, right? You do safety first, then you start doing something, and then you do safety third to double check. I'm picking up what you're saying. I'm picking up what you're putting down.
Yay, Liam.
If it's a 4 amp fuse and all you have is 5 amps, that's probably okay. It's only 25%.
I'm looking through some other boxes here. I got a 15 amp fuse. How about that?
Be better than a 22 shell.
I've got a 3 amp. That's frustrating.
At least there's a nifty note that the load might be low, normal, or high. 1 amp, 2 amp, 3 amp. And that's why they fuse at 4.
Yeah, so 3 amp would not cut it. 5 amp might hurt something.
Really, if I doubt there's wiring that's going to be different rating between 4 and 5 amp.
Yeah, I'm feeling the same way. I'm thinking we're going with 5 amp because I don't have a 4 amp.
And I mean, looking at it, it doesn't look like it. I mean, I can't really tell because it looks like it arced when the fuse wire sprung back. But I mean, it doesn't look like it blew super hard.
I got a 20 amp. We can slap a 20 amp in there and just
should be fine.
Watch the world burn.
2 fuses in parallel, add or divide?
It's 1 over plus 1 over.
Yes, the resistor.
That's right.
So you have to put them in series then.
Yeah, no, we're going.
It's the wrong theory. It's fun. No, I know. 2 4s in parallel should give you 8.
Well, we're supposed to go with 5 amp, but I swear the label there it is, 5 AL 250 volts. So, yep, that's 5 amper. We're going 5 amp. Now, I wonder If that's the only one that I lost. I'm pretty sure it is.
Might be. I mean, that one visibly looks lost.
Oh, no, yeah, that one's definitely lost. I'm just wondering if we lost F3, F2, or F1.
Yeah.
But they visibly look fine. Let me put the multimeter on them right quick.
And you didn't lose primary, because we still see voltage.
Yeah, because we're still generating voltages just fine. Yeah, that fuse is fine.
We joke about using a round as a fuse, but the fuses that they use on power lines are actually designed to explode.
Oh yeah, that's fine.
I wonder if it popped because the power supply got hot, because there's like literally no airflow over the power supply.
I mean, its temperature would reduce its fusing.
Yeah,
I mean,
well, now there is airflow. Oh, because, the sides aren't on it, right? Like, I think you're not meant to run it without the sides on it. What's up, Retro Oji-san? That's a great name. Didn't know you were on Twitch. Happy to stumble on you here. Yeah, I haven't made an official, announcement on YouTube about the Twitch thing happening because I'm still really bad at it, and I kind of want to be better than bad at it before I let everybody know. But yeah, welcome. This is a thing that we do every Friday night. We work on a computer. Welcome, Mr. Hamill. The computer we're working on here is a Litton ABS 1601, I think. From 1969 or 1970, right around there. All right, let's see if it blows the fuse again. Well, we got lights back. Can you guys see the lights, or is it all blown out?
we see lights. There's definitely more than 4 lights.
Had to wait for the stream to catch up.
My buddy sent me a... Huh?
Sorry, Dave.
I was gonna say,
sorry, Dave. Go.
My buddy sent me a meme about Deanna Troi and like how hot she was. And I don't want to get too NSFW here, but he was in the military, so you can put it together. And I within 45 seconds immediately replied with the picture of Troy and Crusher doing the yoga scene, and he was like, "Dude, you were way too quick on the draw with that one." Yeah. All right. So halt, ready, run. It executes a couple of things. It looks like we're back doing stuff.
Turns out we were just missing the most important rail. All logic.
Yeah.
You turned your fan back on, right?
Yeah, it's on.
Okay.
Yeah, it's blowing good air across everything in there now. Even the drum is staying a lot cooler. And actually, I think if we're gonna run this thing more, I think I might upgrade the fan in it and maybe put a second fan directly on the drum or something. Like, I think this thing is kind of inadequately cooled. Even with the sides on it, I think it's not pulling air very well.
This machine certainly was designed.
Yeah, they just want. Yeah. All right, so the next question is like, where do we go from here? What's next up? Like, should we check the Canon connector on the back when we run it to see if it's trying to hit us with anything?
That would be interesting to know, I think, to see if Opus sends a prompt or queries a keyboard or something.
Okay, so we need to know... In that case, I'm going to spin this thing down again. And I need to know what to plug into on the back.
Yeah, the problem is there's like a lot of pins on the back, and I don't think we have enough probes.
Well, yeah, we only need enough to see that it's doing something. I'm not trying to build a terminal for it tonight. I just want to see if Opus is hitting
We should be able to see device select and input and output pulses. So device select will be the first one to look at.
Yeah, like that grouping would be nice. It would be. Do
you guys know what page in the manual that's going to be?
Page number is 3.21, but its page in the PDF would be.
Yeah, when those bearings get cool off, they make all sorts of terrible noises.
Page 72.
Page 72, way up at the top. Dang.
I mean, it's just a 1966 standard 27-wire interface.
Yeah, there you go. All right, so what do we got? Frame ground, circuit ground, so I can pick up my grounds from there. And then we're concerned with
device select common would be one to look at, and then maybe also output common, because those ones get pulsed whenever it actually does an operation.
So it's pin 9 and 10 are kind of what we want to look at then, huh?
Yeah.
Yeah.
That's only 2. We got 2 more probes. Anything else worth looking at on there? I mean, we can do 2. That's fine, but we got the probes.
Input status. I think that's an
number 6.
Yeah, pin 6.
Pin 6? Okay. So 6, 9, and 10.
Oh, and 5.
5, 6, 9, and 10. All right, we can do that. If I can, I mean, they're all like labeled on the back here, so they're pretty easy to get to. I just need something to stab into them so I can actually like plug stuff in.
Oh, nice. They're labeled.
Yeah.
Thank you, Canon connector.
Yeah, Canon connectors are great. The problem is they just hadn't been used in forever, so they're like crazy expensive.
Yeah, that one's $100.
Yeah. Yeah, sounds about right. All right, let's see if I can rotate this enough so that you guys can see what the heck is going on here. I feel like as I'm doing this, I like slowly slide the machine further and further away from the camera.
Where you're seeing the cannons aren't used much. They're still used every day in the military.
These round cannon ones, are they still used?
Yep.
Dang, all right.
I mean, I thought the round cannons was on top of the ship.
Form, fit, function. The equipment has to be the same throughout all the ships and helicopters and aircraft, and they're stuck with standards that are pretty old. I mean, for a brand new jet like the F-22 or something, I'm sure they've moved on to something better, but you don't hear about these things failing very often. The circular middle connectors.
No, they're rock solid. The problem is that I don't have one, so we're gonna have to come up with something inventive when we do want to actually plug something into this thing.
If you can get the pins that fit it, you could probably 3D print one.
Yeah. Or I mean, I can unscrew it here, and we could put a different connector on there if we wanted.
All we have to do is find one, and then we could break it out to something normal. But this plastic available too. You can always get a plastic adapter.
All right, you guys were thinking 5, 6, 9, and 10, right?
Yes.
Okay.
I'm expecting that when we run OPUS, it'll send out some device select pulses to select the printer and the keyboard. So hopefully we can see those.
These are not just a standard Canon connector. The diameters are different. Depending, like pin 5 and 6 are a smaller diameter than pin 1. Okay. That's gonna...
Pin 1 is a ground, so...
Yeah, I wanted to pick up ground off of that, but now I'm running into a problem of I don't know if I can get a good connection on 5 and 6 because I can't get my wires either too thick if I fold it over, too thin if I don't fold it over.
And then I'll need an explanation of what the heck is a DC return.
Also a ground?
Yeah.
They're almost always tied together.
Like 3 different kinds of ground plus shielding.
All right, this is going to be ultra jank.
I mean, that cable was designed to be like multiple meters in length.
Yeah, there we go. All right, let's see here. I think we start with yellow. Yeah,
This
yellow, green.
And this interface is designed to daisy chain through the connected devices, right?
Yeah. And they're using full fat 0 to minus 12 volts. Probably to data integrity.
Same signaling level as like RS-232 around the same time period.
Yeah, but it decided with 0 with the other side. And annoyingly, they don't provide a negative voltage on that connector.
All right, this is not going to work. Hang on a sec. I gotta get smarter. And I already immediately lost one of my cutoffs. Where the heck did that thing go? All right. This is...
With the brads that you use to fix the head connectors fit in there?
Maybe. I'm going to try popping a little wave into my wire here to maybe get some tension going on.
I was about to say, usually if I have like wire that doesn't fit, I'll just form a loop on the end and see if it like springs into place.
I tried that. The loop is too thick. So the wire itself is too thin. If I fold the wire over to make a loop, it's now too thick and won't go in the hole. So I'm making like a little wave, like a little spring contact that's kind of gonna push it. It's much more affirmative feeling. Where'd that extra one go that I cut? There it is. It's like that thing is gonna stab me in the foot.
Now, at least that's a female connector, right?
Yeah.
Good, because male connectors are hard to put wires around.
Yeah. So the fact that it's a female connector makes life a little bit easier. All right, green we're going to put on 9. Then blue we're going to put on 6. And red we're going to put on 5. Okay. That's fun. Bring you back over here to see the scope. What are the voltage levels that we're kind of expecting on these? Do we know? Do we care?
0 to minus 12.
0 to minus 12. Okay, I'm going to need to reposition some things here.
Might be a bit more than minus 12, but I'm not expecting more than minus 18.
Okay, well...
Actually, it should be minus 12. They use the minus 24 rails to generate it.
We're at 10 volts per division, So that'll be, it shouldn't be more than 0 to minus 20, right?
Yeah, should work.
Yeah. All right. Power coming up. Yeah, those all jump to places. So 10, 9 are at, looks like minus 12. 6 is at 0. 5 is at minus 12. Currently.
Okay, now... Oh yeah, minus 12 is a 0. And 0 is a 1. So the opposite of the data 620.
So which one of these are we absolutely certain is going to twiddle?
Output common number
Device
10.
select, I think. Device select number 9. And maybe you might have to rerun Opus and then do a capture on 9. Give that a try. Do a trigger, I mean. Do it.
Yeah, I haven't actually told it to run yet. It's just sitting there halted. So I'm just trying to figure out which channel to trigger on. So you're thinking pin 9?
That's my guess.
Okay, that's going to be green.
Worst case, we're going to try with pin 10 after.
Oh. All right, so I'm going to do a single shot here. We do a halt, ready, run. And we didn't trigger anything. But blue is constantly doing something. Blue would be...
What pin was blue?
Double check. Blue is 6.
So that's input status.
Yeah, okay. So blue, I can get a single shot here.
Maybe it's trying to read the keyboard status to see if a key has been pressed or something like that.
Yeah, I tell you what, let me trigger off of blue. Trigger, so we're triggering off of pin 6. All the other pins are dead. They're not doing anything. But I can zoom right in on blue, and it's pumping something out. I don't know if you guys can see that.
So it's...
That's weird. That looks like data.
Yeah, I was gonna say that doesn't look like a status pulse to me.
I mean, how fast are those pulse?
Well, hang on. Let me grab a single shot here. Well, that is a single shot. So let me take a picture and I'll post it up, because otherwise you're trying to look at it through the Twitch stream, and that's not the best to discern tight quality here.
Yeah, somebody said that looks pretty serial, and we're not expecting serial.
Yeah, no, this thing should not be doing serial. That says that it's like pin 6 should be... All right, hang on. Let me mark down what is what when I post this picture here. Yellow is 10.
If it's input, maybe it's sort of flopping around.
Green
because there's
is
no device connected.
9.
If it's floating, you could also be looking at ground reflection.
That looks way too intentional to be like floating or flopping around or anything like that. R is 5. Now, this is according to the pins on the Canon connector on the back, so I'm just assuming that that matches what the manual says. But there you go, the picture's up.
So we're at 20 microseconds per division.
Yeah. And the first half and the second half are repeated with a long period of low in the middle. and that is on constant repeat. Like, that's not a single shot. That is just the scope live. And it does that same pattern of data, or it does that same pattern, we don't know if it's data. It does that same pattern every 5 milliseconds. So every 5 milliseconds, you get that chunk of junk out the back. Now, if I halt it, that goes away completely. If I hit ready, 6 goes, so the blue goes up to 0. The other 3 are at -12. And if I click run, boy, I don't know. We might have hit off something else there as well. So let's zoom way out. And let's trigger off of source 1, see if it does anything.
5 milliseconds is 1 drum rotation, right?
Yeah, I was about to say that, which would sort of make sense if you had something polling in a loop, waiting for a keyboard input or something, but why it's on that pin, I don't know.
At the same time, don't forget, like, execution every, like, microsecond is, like, something that's super probable with this machine.
Well, that's 1 bit time. It's not necessarily 1 instruction time.
1 bit time is 100. No, you're right.
Yeah, looking at the manual, it should just be like a flagging status or character. So I don't know. With it being that short, it looks kind of suspect.
No, you're right. Like 1 microsecond is just enough for 1 bit time. We would need at least 8 or 16 for a word shuffle. It's like,
and I mean, you can see vestiges too of the logic, like trying to switch to low and then flying right back up.
It's like,
I'll see if I can come up with an instruction we can put in that would just like select the output over and over or something. Just give me a few minutes.
I mean, that shouldn't be too hard.
Yeah, I'm still playing around with triggers here. Let's do a single shot. Halt. No. Let's do a single shot again. Ready. Run. Okay. All right. Let's try that again, huh? Halt. Ready. I'm going to set up our single shot. I'm going to hit run. Okay, all right. So when I hit run, I get a pattern. 5 milliseconds later, I get another pattern. 5 milliseconds later, I get a big, nasty pattern. 5 milliseconds later, I get another big, nasty pattern. And then we get some action on green. Whatever the heck green was.
Green was 9 or device select common.
Yeah, so we get a little bit of action on green. All of the action seems to be happening on 6 regularly, though. And like that's a lot of action on 6, man.
Yeah, that's like too much action.
How long is green pulsing for?
Green pulses for... We get 2 pulses on green. Each pulse is for a little under 50 microseconds. And those pulses are 50, 100, 150 microseconds apart. So you get a 45 or 40 microsecond pulse and then you wait for 110 microseconds, then you get another 40 microsecond pulse. And that's it. Those are the only 2 pulses you get on green. And that happens during a far more intense flurry of activity on blue. So we get like the short regular pattern twice on blue, then we get a more intense pattern, then we get a wildly intense pattern with green twiddling, and then we get a slightly less intense pattern, and then we're down back to the constant loop pattern that we were seeing before.
I still think it's flopping around on blue.
Flopping around is then like, you mean like it's floating or something?
You know, I think that's meant to be an input pin, and maybe it's just picking something up. I just posted an instruction in the chat for which will just constantly select the output printer device.
Okay. So let me put this just on constant run here. All right. CF, I'm guessing that's control. So
yeah, I used the wrong word. So it's 7E41, 7E41, 7E41. Gotcha. Put 73 in there, sorry. I was typing quickly.
Oh, that 7.3 is supposed to be a 7E.
Yeah, sorry. I'm just fixing it
Gotcha.
now.
No, you're good. 7E. Let's see here. So we're halted. We're going to reset you. And we're going to go 7E. And then 1, 2, 4, 1. That's just 7E41 on repeat until we're done, right?
Yeah. So 7E is select device, and 41 is the device ID for the printer, I think.
I can confirm that K83 is supposed to be an output.
Huh.
Well, when the green twiddles and it was flipping to logic high for about 150 microseconds, does that sound like a plausible amount of time for that to be happening?
7E41. 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 7E. Okay. So what are you expecting? Do I need to take like a scope? Well, this should be just something on repeat, right?
Yeah, I'm expecting the device select line will just be constantly pulsing. That's my expectation.
Device select is what pin?
Pin 9.
That would be green. Yeah, it's pulsing like crazy, man. But so is blue.
When it does a device select, it puts the device number out on the bus as well as pulsing the common. So maybe we're picking up a data line. Are you sure that's on pin 6?
I'm pretty sure it's on pin 6.
Well, see, now it looks way cleaner.
Yeah, it's not like a flurry of activity. We just got... Because I'm pretty sure we're seeing pin 6 do OPUS stuff, man. Or we're seeing blue do OPUS stuff. Blue...
Well, it's the green one I expected to do the OPUS stuff to select the device.
Yeah, that's got to be pin 6, man. Like, I can't see any other way that could be anything else.
Hmm.
You know, just think about how much of this computer has to be operational for this to happen.
Oh, yeah, like this thing's in very healthy shape. If we had a typewriter, we could start, like, doing stuff. And, like, really pushing it and see what works and what doesn't.
You don't know how the simplicity of the complexity of this machine could make it do this without much. It is extreme. It's like, this is like literally just clocking out like AND gates and OR gates. There's like not much that's happening. But it is auto-cycling, so that's fun.
Yeah,
Well,
I'm like moderately confident that blue is on pin 6. Green's doing what you're expecting it to do, so pin 9 is twiddling like you like it should.
What's the time between green pulses?
It's let's see here. We're at 50 microseconds per division, so that's going to be. So the green pulse looks like it lasts slightly under 50 microseconds, and it looks like there is 150 microseconds between them. Same for the blue pulses. Also, the blue pulses pulse every time the green pulse goes low. So on the falling edge of the green pulse, the blue pulse pulses, and it's like super consistent.
Part of me kind of wonders in that single shot that you took earlier with the two green pulses and the blue pulse, because those were nicely squared off. I kind of wonder if it's making like one attempt to read or write to something and then going dead, and we're just picking up crosstalk.
It might be receiving a busy signal, but I thought that was defaulting to not busy.
I wonder if status control is. I wonder if like pin 6 is a bi-directional thing where you have an input signal in or a status control signal out.
I mean, I just see output buffers on it.
I wonder if it's wired up differently than the manual states. Which also seems like entirely plausible, right? So you've got, if I understand this right, you've got 8-bit parallel out, 8-bit parallel in. You've got a busy signal that says, I'm not ready for an output. And you also have an input busy signal that says, I'm not ready for an input, which is on pin 7. And we're not checking pin 7. Right.
Both of the busies are inputs.
Okay. Yeah, which is 7 and 19, which we're not checking either of those because they're both inputs.
Yeah, the device select is actually 2 instructions, one that waits for busy, one that just does it immediately. And so the one I gave was the do it immediately instruction. But if we switch to the other one, it probably would do nothing.
Let's try that. What's the instruction for it?
1 second. 7C instead of 7E.
Gotcha. I can do that. What is C in binary?
1100.
1100. Gotcha. So 7. I gotta halt it first. Halt. Reset. 7C. Then we still stick with 4-1, right?
Right.
That's 7C. 4-1. 7C. 4-1. 7C. If I do a run on that, blue is going bonkers. Blue is not what you think, like clearly not what we think is happening.
Yeah, and I'm not seeing a device select on green either.
Yeah. Yeah, green is totally dead. Blue is sending out a very specific pattern. Like this is, it's so intent, like this is clearly not accidental. We just don't know what blue is all. I swear blue is plugged into pin 6 on the back. I've checked it 4 times now.
Oh, I believe you.
Yeah, now I'm asking myself, is pin 6 connected to the right IC? But we're not gonna check. That takes so long.
Yeah, the thing is that I'm fairly certain that, you know, if pin 6 is input only has an input buffer according to the schematics, then either there's something else going on that the schematics aren't covering, or the pinout of the cable on the back is different for this model of machine than the schematics. Oh yeah, I took a picture of that and I meant to post it and then I just didn't.
I'll have to have a think this week to see if there's some kind of instruction sequence we can put into exercise every pin for I/O, and so we can say, okay, we're doing this, we expect pin 3 to be on, but it'll take a while.
I mean, we could write this like I did. We could try to write it to Scratchpad, or we could put it somewhere in the main drum.
Well, we think that when OPUS hits, we're kind of expecting it to send something out in parallel, right?
Yeah.
Yeah.
So if I check OB 1, 2, 3, and 4, that should give us the first 4 bits of what it sends out in parallel.
Let me get you an instruction to actually do an output. Hang on.
I'm gonna move my connectors over to OB. What is that? 10 through 14.
Yeah.
Because it's weird. We're not seeing a lot from the green channel.
Yeah, we're seeing very little from the green channel. But when we told the green channel to do stuff, it did stuff. Wait, the yellow channel is already on pin 10. So actually I want 11 through 14. That's right.
And the timing for that instruction was 4. It's like, I can't math right now, and I don't know why.
All right. So let's go back to run here. And I'm just going to trigger off of OB1, I guess.
Is Obi-Wan the high or low byte? I forget, Rory.
OB1.
Is it the high or low bit? I think it's a low bit.
Like, I have literal sheets in front of me because, like, going through that manual is... I would guess OB1 is low bit.
Okay, then in that case, the instruction I want to try is 7855.
Okay. So we definitely get a collection of data out.
Is that still running the previous thing?
No, that is a halt ready run.
So that's maybe Opus putting something out. Written a prompt maybe.
That was shot so fast it rounded everything out.
Yeah. So that's the first 4 bits. They look identical. And then there's a long delay, and then you get another shot of identical stuff out the backside.
Can we maybe hook up pin 10 as well, the output commons, so we can see the trigger?
Yeah, we never saw the trigger. It was the weird one.
Yeah, I'll sacrifice purple for that. So we'll get OB1 is on the bottom, so we'll get OB1, OB2, OB3, and then pin 10, which would be the output common, right?
Yeah. Yeah.
Okay, so we're going to sacrifice 14 for 10. If I can get to 10. All right, I think that should be doing something. So we're going to hit single again. All right, let's go back to run.
Well, somebody was noting that the traces were a bit offset. That would make sense because they're getting clocked in.
Alt, ready, run. Okay, whatever I'm triggering on didn't trigger. Oh, that was really slow. That time it did trigger, and we got nothing, so...
It's possible it's basically waiting for it's polling the output busy pin, but that's weird.
Yeah, I don't see anything on output common.
Yeah, I don't think we understand how this damn connector works.
Yeah,
that seems highly likely.
Have we checked for voltages or anything obvious that would indicate that maybe Lytton is using a different numbering scheme than Canon?
That's also entirely possible. I wouldn't know how to check for that. I do believe that the power signals that Lytton has listed in there match up because those are fatter pins on the Canon connector. So at the very least, I'm pretty sure that 1, 2, 3, and 4 are correct.
And they're not all vertical or anything like that that would not tell you if they swapped the thing left to right or anything like that?
No, it's just a big mess. And they're not even in, like, order. The numbers are kind of all over the place.
Okay. All right. That's a reasonable hint then.
Oh, can we have a photo of the Canon connector?
Yeah, it's let me carefully unhook my scope here. There we go. You gonna focus for me, camera? $78 AA. Output media of A8 hex. Change the AA for other bytes. 7855. I take it you want me to punch that in and check it out, huh?
Yeah, although I think that it might just poll for output busy and then just not do anything, but we'll see.
Yeah. Okay. So I should be checking the what pins again? 10. We're still happy with 11, 12, 13, 14, 11, 12, 13, 14.
Yeah, that'll give us the bottom 4 bits.
Okay.
Okay, that's fun.
That connector is weird. Like, who the hell thought that was logical?
Yeah.
What?
Like, everything's in, like, crazy places, right? All right, so I'm going for 11, 12, 13, and 14 here.
I mean, that doesn't look like the 32-pin Canon connector I found. Great. We need to find what the heck that one is.
Yeah, I have no idea. Like, I think what we're going to have to do is just... I don't know. Like, it feels bad and feels wrong saying it, but, like, it makes more sense to just come up with an adapter somehow.
I mean, you could maybe drill out a PCB with exactly the pins at the right spot, and we just put mechanical pins.
Yeah, but I got to find the right size mechanical pins, right?
Yeah, but I mean...
Does that Canon connector have any... Does that go to a ribbon cable or something on the back that connects to the PCBs on the other end, or what does it do?
It goes... Hang on, let me get this hooked up without shorting everything out right quick.
Good question. I don't even know where it goes. Might go to the F board. I don't know.
I was just thinking that if it goes to an edge connector on one of those boards, then we could just go onto the edge connector instead.
It goes to, yeah, the edge connector on the board. That big sideboard. That board that I was unsure what it was, I'm pretty sure that's the output drivers and input receivers. Because that's where the Canon connector seems to go.
Well, that gives us somewhere we might be able to hook in then.
Yeah.
At least it's not a flat flux.
All right. So what am I punching in here again?
7, 8, AA, over and over.
Okay. Starting with control.
Yeah.
7, 8. We've already got 7, 8 set up. And then AA is what in binary?
1 0 1 0 1 0.
1 0 1 0 1 0 1 0. And 7 8.
I suspect this won't do anything, unfortunately. I think the device select is the only one that doesn't wait for busy.
7 8. 1 0 1 0 1 0 1 0. 7 8. Okay. I'll take a single shot here, triggering on source 1. So we'll hit run. And nothing.
Yeah, that's what I thought. Yeah, I think the device select is the only one that we'll be able to do that doesn't require us to toggle the busy line.
Did we just not unhook all of the scope probes?
I just hooked them back up.
Okay, good.
What you might want to do is change that 7 8 to a step back 7E, which was the device select, and then we'll see if we get the device number AA actually show up on those lines.
Okay. So 7E. Here. I gotta halt it. That's 7. There's E. And then AA. 7E. And then AA. And then 7E. And then AA. And then 7E. And then if we hit single shot and hit run, well, you got something going on there. Let me get a. Oh, it's on like it's on repeat.
Yeah, because it's sending the dice select over and over.
Okay. Is that kind of what you were expecting to see?
That's noisy as hell.
It is a little noisy, but then again, it is very janky. My scope probes are set up in the jankiest of jank.
So what we should we expect to see, I expect to see like 1010 there. And I mean, I think it's got it there.
So yeah, 1010, then 0000, then 1111111111, 0101 until the next repeat.
Yeah, I think it's doing it.
So if we change it from AA to something else, we should get a different pattern, right?
Yeah, if you get a 5-5, that should invert the bits.
So let me take a picture of this. And then I'll go to 5-5. Halt it. Oh, I can't halt if I'm not in control. All right, there we go. Halt. We stay with the 7E.
Yep.
And then we just go to 5-5 instead.
Right.
Starting to get a handle of how this thing does stuff. All right, and then if I hit run on you, hit run on you, take a single shot. Take another single shot here. Boy, that's noisy. But if I compare this to my other picture, we have some extra like spiky spikes going on down here. But the previous picture was, let's see.
I think it is inverted. At least the like not where the pulses are, but in the flat sections, it seems to be the other way around.
Yeah, I think so. Oh, maybe well, no, because those are all high at the same time. Like these all four go low at the same time. Yeah, I don't know what I'm looking at here.
Yeah, I get it.
Well, okay, so if you look at not this part here, so if you look at the not noise hell, it is actually completely inverted.
Yeah, that's what I was saying before.
Yeah.
The flat bits.
So the question is, what is this hellish noise stuff that's going on right here? It's like it's sending something else on output in between sending the actual character on repeat. So like,
yeah, I'm thinking the noise is actually not the signal. The signal is the stuff between the noise.
Yeah, I think you're absolutely right. I think this is the signal getting sent, and then this is like processing power to do the loop, and then this is the signal getting sent again.
Yeah, that might be it.
Because that makes perfect sense, because this now becomes 0 or is 0 volts high and negative 12 volts low, or is it the other way around?
Negative 12 is low.
Okay, so this becomes 1010, and previously it was 0101.
Yeah, so we inverted it. Yeah.
Yeah, so we absolutely inverted it.
Could we perhaps hook up pin 9 again, the device select, and then we can actually see where the device select pulse is with comparison to these levels? Because if it falls in the middle of the flat section, then that would explain to not look at the noise.
Yeah. All right, so device select is pin 9, and I'll sacrifice pin 14 for that. I feel like we've done this before. I feel like I said that exact same sentence before. But
Yeah.
I'm going to sacrifice...
Yeah, before I was trying to be smart and just select the printer, but now we're just selecting 1010 and stuff, and it's easier to see.
All right, there's pin 9. It's actually a lot easier to get to. Okay. So we're looking at, it's still on loop. I just need to take a new scope shot then.
Yep.
Oh, yeah. So, yeah, there you go. So pin 9 goes from negative 12 volts to 0 volts right in the middle of the data.
Okay, so whatever that noise is, it's just signals flopping around or something.
Yeah, it doesn't matter to us. We don't care because the select happens at the right timing.
It's loading in the parallel value.
Yeah, that's really cool.
Okay.
There's no blanking on this thing. It's just everything's loaded serially into the buffer. So if you're not looking at the clocks, it might look completely weird.
Yeah, I-2097, you got it right. We're clocking on the flats. That's perfect.
Awesome.
Yeah, so we're getting a better idea. The device select we know is on pin 9. The outputs we know are on where they say they are. Pin 6 is the only mystery currently.
Mm-hmm.
But that flopping about on pin 6 may not have been happening at the right, at a time that we care about, right?
Yeah, and actually, it's like I don't even know exactly where it's getting derived, so yeah, I'll need to check up on that.
I think we made a lot of progress, though, figuring out what's going on that connector, though.
Yeah, I mean, I'm suddenly not terrified of the connector anymore. I don't know.
We just need to find the right clock pulse to sample it on the input and output.
Yeah, but and the connector itself is these two card edge connectors on this board right here. Whenever the Twitch stream catches up. So we don't even necessarily have to disconnect the Canon connector. We can just solder flying leads off of these to a new connector that we just hang out the back, like a DB25 or whatever, right?
Yeah.
Problem solved. Except that there's like 32 pins, but we don't necessarily need all 32 of those, right?
There's 27, but
some of the shit spare.
So yeah,
there's 32.
You definitely need the 8 for the input, the 8 for the output. That's 16. You need output busy. That's 17. Output common. That's 18. Device select. That's 19. Inhibit is 20. Input busy is 21. Input status is 22. One clear is 23. And then we've got a ground for 24. And that's it. That's it for like what we're going to need on like a microcontroller. So we could slap it into, we could also put plus 18 volts on 25, and I think that's pretty much everything.
I mean, like in my design, I just needed the DC return, and the plus 18. What can we do with plus 18? Like
we could use it we could regulate it and use it to power whatever translation device that we build.
True.
And whatever level shifters we need and stuff.
But the problem is like how you produce negative voltage from that. It's like, so.
Well, you could use a Max 232 and to get or some kind of RS-232 line driver to get negative voltage.
Yeah. There's lots of options. Like
my my solution was to just avoid it because they are naturally getting pulled to the negative voltage. So we just have to pull it to 0. And because they're not giving me a negative supply, I'm actually pulling a bit higher than 0. But not by much.
All right, so now we know where it's clocking. Let's change our trigger to source 4 here, which I should have been doing from the beginning because that looks way cleaner now. Let's slow it down a bit. I'm going to do a halt, a ready, and then I'm going to hit a single shot here, and then we're going to go with a run. And there we go. We get 2 clocks of 0, 0, 0, and then followed by a 1, 0, 0. So it is trying to send 2 8-bit values in rapid succession when we run Opus.
Question: do we have? Are we looking at line 9 or just line 10?
We're looking at line 9. No, we're looking at line 10. Just line 10. No, line 9. Okay. 9. Because 9 is the device select, right?
So it's trying to select something, and then it's trying to select something else. Might be logical because there's the printer and there's the tape.
Printer and keyboard and punch tape. Maybe it's waiting to load from either keyboard or punch tape or something like that. Yeah, we need to just load this to figure out what's doing it set up.
All right, well, okay, so
I'm hearing.
So if I'm looking at this, the first time it hits it, our green, yellow, and blue are all low. The second time it hits it, our yellow goes high, but our green and blue stay low. So we know that blue stays low during these first 2 device selects for Opus. So if I change blue to pin 10, that'll tell us if it's doing an output or an input, if it's pulling for an output or an input. So let me do that right quick. Are you guys following?
I'm not sure that's going to work. I'm not sure that's going to work because I think it only does the output common after it knows that the output's not busy.
Well, so if we don't see blue do anything, then I'll switch over to input as well, right? Like the point that I'm getting at is that we see it change the value on the green and yellow there, right?
Yeah.
So what was I saying? Pin 10?
I think so.
There we go. So we'll get blue on pin 10 now. And if we don't see blue change at all, then if we don't see blue change at all, then I'll swap over to input common. Where's that at?
That would be, I don't think it really has one.
Or K83 maybe, pin 6.
The input normally asks for clear, I think. So K150, it's on pin.
All right. Yeah, blue doesn't change anything at all during that. So let's check input status control maybe, or maybe we should check output busy. No, output busy is an input, right?
I'm thinking pin 5, the K150 clear, because that's actually sent just after it finishes reading the input bus.
Okay, we can try that. All right, pin 5, and then we'll go over to pin 6 maybe.
We're gonna have a lot of fun with an Arduino Mega connected to this thing.
Yeah, well, that's the thing. I'm just trying to figure out You were trying to get an idea of what we're expecting to build here. Halt, ready, run. Nothing on pin 5.
Maybe next week we can have a look at seeing if we can make the busy lines go low so that we can actually try to put data in and see what happens.
Halt, ready,
pull them.
Run. Ooh, all right. Pin 6 does stuff, though. Pin 6 is the input status control.
Yeah, it was the one that was going wild before.
Yeah,
how is it correlated with the clock pulses?
Here's the thing, though. Like, when we do a device select, in the middle of the device select, we see the input status go low. And then at that point in time, our output signals are both low. And then on our next device select, our input signal is continually high, and our outputs have changed slightly. So I do genuinely think that it's selecting an output device and sending something to an output device.
Or an input device, like waiting for a keyboard input or something.
Right now, I'm thinking we're really getting stuck on the busy signals. Because the only thing that wouldn't need a busy signal is to select an address. And that's the only thing that we have control. You can't answer busy to change, are you this address? But you can respond busy to receive this data.
Yeah, T Neils 1 over on Twitch. Yeah, we didn't get I didn't get the typewriter or the paper tape punch and reader that's supposed to go with this thing. Ultimately, I want to have a Teletype Model 43 and a mag tape unit connected up to it, but that's going to require a kind of translation board to go between the two. I do want to build that translation board as period correct, like using ROMs and UARTs and whatnot, mostly period correct for mid-1970s. But for the time being, until we understand what the heck is going on with how this thing communicates, we're going to use just an Arduino. So that way we can rapidly iterate, change code, get good traces on the serial console that the Arduino software has. And then once we have a good idea of how this thing is communicating with the outside world, we will start to develop a translator board to go between that and some RS-232 devices. Is the goal. I don't know how many I/O pins an Arduino Uno has, but I already have an Arduino Uno. So if it's got 25, then we need 25. If it's got 23 I/O pins, we could just straight use that.
I don't think the Uno has enough I/O, but
the Uno's got a lot, man. Because all of the analog I/O on the Uno can also double as digital I/O.
Yeah, maybe.
So T Neils, is that 14 digital I/O, not including the analog I/O? Because there's 10 analog I/O pins, I want to say. And you can encode, change the analog. Any analog pin can become a digital input or output just by setting it up as a digital I/O, if I remember. It's been a while since I've messed with the Uno, but I mean, I'll order a Mega anyways, because I should probably own a Mega.
Seems to be 20 usable pins.
That's getting pretty close, man.
Yeah.
Don't forget, you got to level shift everything.
Oh, I mean, I have the
12.
level shift, pretty sure I have the level shift down. It's a bit nasty, but should work.
I mean, you can buy those little transistor boards, at least for the testing.
I'm
Yeah.
I mean, I only need one transistor in one direction, but
so the good news is that we haven't blown our 5 amp fuse yet. So I'm pretty sure that our fuse was just old. So that's
and
excellent news.
We now have 1 extra amp of leeway.
Yeah. And we got 15, 16, 30, and 31 at 100,000 samples, which should be OPUS. OPUS should be in one of those, or 2 of those 4.
I'm going to try to get some data out this week, hopefully. And if I can't get it out, hopefully I'll know what to tell you to get next week.
Yeah.
Yeah.
So here, I'm going to spin it down and then stand in front of the camera for a second. We'll go ahead and turn you off. The drum, once it warms up, the bearings sound fine. It takes the drum 20 minutes for the bearings to get warm. Because it sounds smooth and I mean, I don't want to say quiet because there's nothing quiet about this machine. But it's not like squealing or humming or making weird noises like it was before. So what we learned today is that Twitch had a real hard time in the first 10 minutes, and then it kind of got better. We learned that a 5 microfarad cap seems to work in place of the 4 microfarad cap. The machine seems to be working. We're pretty sure that your programs to put a single track just on constant repeat for the scope seem to work out great. And so we think we've got OPUS. We're not sure. We'll figure that out this week. So for next week, I'm trying to figure out what I need to order, buy, or prepare for next week. Because we're at a point where, like, the stuff that I have available to me in this room is no longer going to be enough to push us towards the next step of, like, starting to use this machine.
If you could determine the pin sizes that go in that connector, it may be helpful to get some pins you can crimp onto some heavier wires to work with, and to break out to a better connector.
Yeah, that might not be a bad idea.
And
it's like multiple different pin sizes. I don't know how I would be able to measure that, because like the pins are inset deep enough that I can't really get a mic and a micrometer in there.
Can you measure the shell? And actually, if you look on the outside of the shell, whatever is visible, is there any writing on there? I spent like 20 minutes or half an hour just trying to figure out what connector that is.
Like on the outside, on the back, there's no writing. It just says Canon. On the inside, again, there's no writing.
What it may be is that
potted.
There may be writing on the flange that's hidden behind that sheet metal, behind the case. The other possibility is the edge, but you probably can't see that.
Was there a parts list in the PDF?
No, not really.
It says standard 27 pin, and you can see it's 32 pins.
They say it's a 32 pin Canon connector, and the standard is 27 pin 1966 standard. I I've even asked an AI, say, oh, there's a 1966 standard that exists. It's like, give me documentation.
Don't trust an AI,
find
man.
any.
Yeah, don't
I
trust
know,
it.
it's
It's
not
probably
good.
just making
I know.
up stupid BS.
No, I know.
The AI has no
I
clue.
asked for doc, and it went, oh, it might be in a IEEE document or something. Great.
I've seen.
You know what? How many fat power pins were there?
4.
Yeah.
So 27. That gives you 31. I wonder if the 27. What did it say? 27 pin was the standard.
Because that's how many are populated.
That's how many are signal pins, not voltage or ground. The shield. I bet they're count. Does the 32 pin count the shield as one of the pins?
No, but it counts frame ground as one of the pins.
That's what I meant. The outside, the part you screw on.
Unfortunately,
they
Adam,
have an extra node as shield. So
unfortunately, there's not any extra additional writing on this thing.
Yeah.
What I'm getting at is there might. So I saw a couple of pictures that showed writing. Like you'd have to actually unscrew it, which I'm not suggesting you do. You'd have to unscrew it from the case of the computer.
Yeah, too late. Too late. Already did that. Check the picture in Discord.
Oh, and there's nothing else there, huh?
Yeah, nothing. No, they're not giving us anything, man.
Wow.
Yeah, that's why I'm saying, like, ultimately, I think what we'll do is we'll just leave the Canon connector where it is and solder flying leads to that interface board that the Canon connector plugs into, and just run that out to like a separate.
Can we have a photo with a scale so we can maybe gauge it by the image?
Gauge what?
Size of pins.
No, you're never going to get it close just from a picture, man. You got to get in there with like a micrometer or something.
Litton is pulling some bullshit here too, because there's supposed to be a back on that, and you can even see the threading for it in the picture of the rear, and they just potted it.
Yeah, that's like super frustrating that it's all potted on the backside. You can't change the pin out even if you wanted to.
Imagine one pin gets bent.
Yeah.
Now, if you have some round feeler gauges, you could use those to try to get a size for each pin.
Yeah. No, I honestly, I think it's just easier, safer, and smarter to just go off of that edge, the side panel there, where the edge connectors plug into. Because like there's no solder mask on the thing, so I can just like straight solder to traces or whatever, and we can just run 20 new wires out to a plug somewhere. And then just plug a DB25 into it. Like, just make life super easy.
Yeah, no, I think you're probably safest that way. I mean, I linked one that's similar. I have not found anything that has that strange layout with the 4 pins. They may have, I mean, Litton was doing military. They may have had Canon custom make this, or it was from a particular plane and they're reusing it on this. Who knows? But it's not any of the mil standards I checked.
Yeah, I think I can do this. I think I can slip a DB25 with the cables coming up, over, and around and secure it to the wooden top with a little bracket. I would have to drill holes into my wooden top here, but I think that would be fine. It's just MDF with some laminate on it. Oh, nope. I think it would probably catch that thing when it's on its way in. Dang. Okay, I'd have to rethink that a bit. Now, I'm pretty sure that, like, I can just... Like, I can see where all these things plug into. And it's a single-sided PCB, so, like, I can see all of the connections right here. Yeah.
Yeah. even my design only needed 24 pins, so yeah, let's just slap a DB24 on that.
Yeah, I'm pretty sure that like that's the easiest way to do it. And then I just got to find a way to get the DB25 out of the machine, preferably without cutting holes and stuff. But yeah, we can do that. So I suppose that's kind of what we're aiming for next week then, is trying to get that parallel input-output stuff going on. If I'm going to start building that next week, then I want to make sure that I've got all the right supplies in hand. I mean, because at the moment, I can't see anything else that we can do with this machine that doesn't require us to have some kind of I/O going on, right?
Not that I can think of. So the thing to start planning during the week maybe would be what form you want that I/O to take. I mean, do we have manuals for any of the I/O devices? Because when you are writing a machine emulator, the I/O devices and their various machinations are always the hardest part to emulate correctly.
Yeah.
The software makes assumptions about them. They tune delays. They steal each other's signals and stab each other in the back. There's all kinds of deep holes to fall down into. So anything that you can dig up, and it may not be from Lytton if you find out that they rebadged somebody else's crap. Like my current thing is making a particular deck option go, and it turned out it was a rebranded data products device, and all the deck manuals had evaporated, but I found the data products manual, and that had what I needed. Sometimes you have to go digging through patent applications, all kinds of stuff.
The 1231, the ABS 1231 operator manual includes sections for each peripheral. It doesn't get down to the signal level, though. I don't know if those exist, in a searchable form.
But the thing is,
if we can pull apart OPUS, we should be able to see how it's operating the devices and then get it from there. But it's not the manual.
Exactly. Yeah. At that level, yeah, we got to get down to OPUS.
But if we can get like a microcontroller onto the output pins, then we can, look at what OPUS is outputting. God damn.
Yeah.
We can look at what OPUS is outputting and start to make some guesses at what OPUS is hoping for input. And if it's an Arduino, then it's super easy to just go from there, right? Because you just update the code, flash the Arduino, try again.
Yeah, there's that, but I was also thinking, you have a whole bunch of people here. We can divide the work up according to who's got free time to do what, instead of you doing everything.
Well, I'm barely keeping up. The people here have done most of the work on this thing. I'm turning the wrenches. I'm just a remote controlled robot that turns wrenches. That's all I am.
Yeah, I don't know how much crazy quirks that are gonna end up, because they really went there's one standard for every type of device that plugs on it, and OPUS has to be able to talk to every one of those. And this device was not made to be plugged on anything you want. It was Lytton products from their electronic business systems. So.
But they had some interesting stuff. You could put the whole second drum on the thing.
Yeah, and I found M170 seems to be where it plugs in. It's a weird collaboration between the back plug and maybe something special inside. Because there's like the block exchange instruction talks about if the external exchange block device is available. It's like, what external? There's not even a way to tell the command to use something else. Like, what are they talking about? So that might be linked to the external drum. But
Could be. That's
yeah.
I mean, ultimately, all we really care about is typewriter, tape reader, tape punch. That's it. Like, if we can get those 3 external devices working, then the whole thing works. Because that was like the bare minimum setup, which means that Opus is not going to be dependent on something that was an option.
Yeah.
What about your? I thought one of the goals here was also to work with all those tapes you have.
Depends on which. Oh, the paper tapes?
Yeah.
Yeah, we'll digitize those and convert them to whatever we end up actually running.
But it wouldn't be hard to move that to Arduino code or something like that. Just to, we don't have to build a physical paper tape reader for this.
No, that's not the goal. So my goal is to use. This is like scrap. This is like the scrapyard battle thing. I'm just using stuff that I've got in the room. My goal is to use this Tektran here. Whenever the video updates, it's going to take a little bit. This is the Tektran 817. Uses a regular like cassette that goes into it. I bought this on eBay as a backup for VCF Southwest in case I couldn't get the other Tektran working in time. And now I just have 2 functional Tektrans. So I don't have anything to use this on. So this is like very similar, fun aesthetic to the Teletype Model 43. This communicates via serial. So if we can create an RS-232 to, whatever the heck is going on with Lytton converter, then it doesn't matter. Like the data cassette doesn't care. So we take all the parallel data from the tapes, digitize it, and then you just send that over serial via the data cassette.
And then our interface makes it parallel and makes it available to the Lytton.
Yeah. Yeah, so the Lytton doesn't see anything different. Because our converter, our translator is changing it between the parallel interface the Lytton is expecting and the RS-232 serial.
Yeah, the only other thing I could think of that you might or that it might expect as a printer, because back then printing out documents for customer billing or what have you was every computer's bread and butter.
Well,
so I would be surprised if it expects that. That's
why they had that big honking typewriter as your main data terminal.
Oh, it didn't have a separate printer option?
No,
It does.
It has a weird. That printer actually had a weird thing where you could actually have independently line feed both halves of the paper, and so you could actually have like your user interface on one side, and then you have invoices or whatever you're printing on the other. It's kind of weird. So you have one printer for both.
Yep.
Yeah, that was very common. That kind of crap. If you look at the IBM System 32, that's how it was originally designed. The CRT was added as an afterthought.
Nice. But that printer was pretty speedy. Not drum printer speedy, but 36 characters per second.
But ultimately it doesn't matter though, because you've got the busy line, right?
Yep.
So Opus is never going to send things faster than the busy line. So we just hold the busy line until we're done printing at whatever speed we end up at, 300 baud, or I think the I think the Model 43 can only do 300 baud.
I mean, it's close to 300.
Yeah, but it doesn't matter because we're asynchronous at that point, right? You just hold it. You just hold a busy line until you're ready for your next byte. So but I think what Suzerain's got a good point in that, like, I think we'll get to a point where we have like basic core functionality and we're seeing Opus talk to us just fine. And then there's going to be about 9 million gotchas as we try to get deeper into software that becomes more and more reliant upon the unique layout of their I/O system.
I mean, we're still arguing if it's actually ASCII or they actually are BCD on their line, because well,
that's
one manual says one.
That's what we're hoping to find out next week, right?
Yeah,
you know,
we'll know from Opus.
Yeah.
Oh yeah,
if we can get it decoded this week, we'll know.
Okay. Assuming that it actually was dumped, okay.
Yeah, and if it wasn't, then we know next week. Hopefully, we'll know next week what to change so the next time we try, it does dump correctly. Like maybe 100,000 data points wasn't enough, you know.
And if the tech tram doesn't work, here's a Lytton specific cassette option.
Oh, great! More Lytton stuff that I need to buy.
This isn't. I don't know if that's period correct though.
Yeah, that's the hard part with Lytton stuff, man, is that like they made stuff for so long for so many different people. You never know. Like it's surprisingly difficult to find information on this Lytton computer because like your search just gets inundated with all the other different stuff that Lytton made.
Yeah. Monroe, Royal, and it looks like in the 70s they were making everything slapped onto a calculator. That's a cassette player slapped onto a calculator. They have a clock on a calculator.
Yeah, I just want that 12,000 RPM drum miniaturized and in a calculator.
Yeah, that drum is like when it's not humming and making horrific noises, it's very cool, and you can tell that it is moving.
Anyone else?
You go.
Anyone else remember the IBM Micro Drive?
Yes, the and the Palm Life Drive that used it.
Yep. Bob has a very cool display at his museum where he's got the micro drive cracked open so you can see the platter. And then he has a platter from the largest hard drive ever made, which was like the Ramac or something like that. The platter that's like, 4 feet in diameter or something. He's got the two of them sitting right next to each other. It's really cool.
And you can buy those micro drives are actually relatively cheap. It's like they're like $20-$30 now for the 1 gig.
And the micro drive is how many orders of magnitude more storage than the enormous platter?
Oh yeah, considerably.
Yes.
3, 4, or 6.
Yeah, a lot.
I've got a Seagate 1-inch hard drive that's 5 gigabytes. I mean, it's yeah.
We got a few minutes here before I go to sleep. I'll show you guys a little something that I built.
Oh yeah.
Here we go. This would be the Data 620 card tester.
VersaLogic card tester.
Yes.
And that's the 12 NAND gate.
Yeah, this is the GA112 that's in it right now, I think.
Yep.
And we'll go ahead and turn it on. There we go. Should have some nice Christmas lights going on here. whenever the stream updates. Can you guys see the lights yet?
Yep. So all the outputs are 1.
Actually, no, because the LEDs are backwards. 0. Yeah, so all of the outputs are 0, all of the inputs are 1. And 1, 1 on a NAND gate gives a 0. So if I turn any input on, that turns the output off.
Yep. I managed to invert the input in my head and forgot about inverting the output.
Yeah, the issue, like the problem is like the Lytton is using 0 volts and negative 12 volts, but it's using it backwards from how this thing is using it. So that's the GA112, which has 12 NAND gates. Oh, I just made a mess. Excellent. I've got a couple other cards here.
About automating the testing there.
Let's see here. We'll do a GA27-1. That's a GR26.
Technically, the logic I'm making for the Lytton would work with VersaLogic, but like I'm gonna be loading the outputs maybe a bit more.
All right, so that was a GA112 with 12 NAND gates. This is a GA27. This has 7 NAND gates that are 4 input each. So if we flip the power switch on for that, you get fun little collections of LEDs. So the rightmost LED here, the 4 inputs are the 4 to the right of it. For the leftmost LED, the 4 inputs are the 4 that are to the left of it. Oh. There. Yeah. So all 4 of these have to go off for the output to go on. All 4 of these have to go off for the output to go on. And then we can stress test the output by flipping the toggle switch up to see how bright the LED gets. So this GA27-1 is fully working. All the logic works fine on it. Now we get into the more difficult ones to test.
Have you tried the flip-flops?
Yes, to not a whole lot of success. Let's see here. What's up next? This is a GR26-1. Pretty sure this is 3 2-input NAND gates connected up together. So you've got 4 inputs for 1 output, and there's 5 of those. Right? So I think, yeah, those are the 4 inputs. It's a very weird design. The schematic outlines a little better what they're doing.
Which one was that?
GR26-1.
GR26-1.
Yeah, I'm fairly certain that it's working correctly.
Oh yeah, it's like a...
Oh, you get dual outputs. That's what it is. Yeah, so you've got a positive and negative output coming out of it, and you've got 4 inputs.
Oh yeah, I remember seeing the diagram in that one and saying, "Oh, that's completely not the." Yeah, it has complementary outputs.
Yeah, so it's 4 inputs with complementary outputs. So this one actually works just fine. I can test GA27s, GA112s. What was this one again? GR26s. I mean, that's already like more than 50 of the cards in the machine. This is a PA24.
Oh, I know that one.
I think this one was a bunch of inverters.
Actually, that's the thing.
This was a weird power amplifier one.
those are just power amplifiers, and in the brochure, they say they're straight output. So whatever's put in should be out without inversion.
Yeah, these are buffers, and you get 2 outputs. So 4 inputs.
Yep.
Hit both outputs. Any input turns the output on. Now the outputs aren't a full low. I can see that. So I think, you know, they're not being pulled as low as I would have expected. Oh, this one has a bad output. So one of the outputs is bad. I think you're supposed to have a double output on the far left, and we only got a single.
Oh, so they're missing a wire.
Either that or we got a bad output transistor. Like this toggle doesn't kick it on either.
They're physically connected. It's a straight wire.
Oh,
but
yeah.
The far left one might be using a jumper. So there might be something weird with a link.
Yeah. So this card actually has a fault on it, I think. So
I'm the one
fantastic.
that made the schematic for that one.
And then here's the FF26. The flip-flops really do not like working.
Yeah, because they have a clock, and it's a weird bucket brigade capacitor thing. It's like...
Yeah. And if I remember... So I think what's happening is I'm getting a race condition.
And that one
there we go.
Is... I had trouble simulating that one.
So this one I'm starting to get to work. I should have filmed with this one.
Which number is that one?
FF26. All right. So actually, I think I've kind of figured this one out. If I remember...
That's 6 flip-flop, and...
Yeah, so you've got a flip-flop here with complementary outputs. You've got 2 bits here for your set or reset. And then you've also got 2 bits for a corresponding clock.
Yeah, and technically they shouldn't be able to set or reset without the clock being pulsed.
Yeah. So I can say, let's go for a reset, and then I pulse the reset clock and it resets. And then I can say, let's go for a set, and I pulse the set clock and it sets. So this one actually works.
Yeah, that's how they're supposed to work.
Yeah, but I was trying this earlier and it was not doing that. And then you have a global reset here on the far end. So I swear I tried that with this one up here. So if I set you... Oh, yeah, no, that's all sorts of weird stuff going on. Something's broken with this one.
Oh, so there might be a fault.
Yeah, that one has a fault, I think. So we set you, toggle you. No, we set you, and we toggle you.
Might be a bad cap or a bad diode.
You. Nope. No. Set you, toggle you. Set you, toggle you. Yeah. So that flip-flop works as it's supposed to. That flip-flop is bad. We got a short on that flip-flop. So this card has a bad flop on it.
That's nice.
Yeah, so the FF26. Yeah, the card tester can test the FF26. Now, I was trying to test the FF34, and it would not play nice. Let me grab an FF34 out of the machine right quick. So, yeah, the reason that that's right. The reason I didn't film with the FF26 is because the FF26 is not used in the CPU. It's used in core memory and I/O. But the FF26 definitely seemed to be working a lot better. I tried to do it with a Reg 04, and I couldn't get a single lick of anything out of it.
Oh god, Reg 04 is a very dense and complex register bit. Of actually 5 register bits.
Yeah. All right, so here's FF34. And this one, I was having, I could not get it to do, like this one I think also has a global reset. Yeah. And then I was trying to do it the same way that I was just doing the FF26 there. But it won't do anything. So I've got to do both the clocks. I was able to get it to do something if I do both the clocks at once or something. It was like, the FF34 does not play nice with this. The global reset does. So if I powered it on and these are in like a weird state, I can toggle the global reset and it goes. But the rest of FF34 does not work right here.
Yeah, they have a weird clock pull-up bias thing that are all common together. I remember seeing it and I was like, what the heck is this?
Yeah. Yeah, I don't remember how I was getting it to do something before. Yeah, so the FF34 I don't think is going to play. The FF34 and the Reg 04 I don't think is going to be testable with this setup. I think they're expecting very specific pulses with very specific timing, which is kind of unfortunate. I did put the arithmetic in there, but like I didn't know what was input or output.
So my best guess is the arithmetic really requires the Reg 04 to be connected, or something weird like that.
Well,
they tell that the bit slices are vertical, and the only thing that's near the arithmetic is the Reg 04 right over it.
Yeah, so with the with the arithmetic, this is ARI 01. You can see that we get some stuff going on, and there's a bit around here that causes something over on the far side to change. Yeah, there we go. So this bit, if I flip this bit on, that causes a bit over there to come on. And I don't remember, because I was trying to figure out if there was like, I don't have the schematic in front of me, which is the problem. Like you really do need the schematic to tell. So yeah, I think this one will also do something. No. That one affects this one somehow. When this one's on, this one affects that. That one also affects it, as does that one. So if I do that one, yeah.
It's hard to break our mind to think that this is only one bit, but it has to do everything an ALU does.
And I'm sure it does. I'm not like I currently don't have the schematic, and so I don't fully understand how the arithmetic card is supposed to work and like what the combinational logic coming out of it is. But I'm sure if I spend enough time sitting down with the schematic, I should be able to figure out, like if we toggle this switch, we should see some change on this bit.
Yeah, there's a lot of spaghetti in that design.
Yeah, well, it's a very complex card.
I think it's the one that has the most transistors.
Yeah, if we do a Reg 04 here, I'm pretty sure I didn't get a single bit of life out of the Reg 04.
Yeah, that's the first one I did. So, well, I didn't do the PCB. I only did the
That's already a weird collection of LEDs lighting up.
The ones that are lighting up are, yeah, some of them are the outputs, but some of them are just like ground connections.
Yeah, if you just have a ground connection, that lights the LED up.
Yeah. So if I wanted to play with that board, I would be concentrating on the bus set and the bus reset.
Yeah, that's going to require sitting down with the schematic.
Yeah.
And the flip flops, I think they're expecting spikes or clock signal of a specific width to get the right transient going on, and just like the DC switches are not going to cut it.
Yeah, they just need a transient from I think 1 to 0. And the weird part about Reg 04, actually, just a note, any card that has a 0 for the first digit is a custom card, and the rest are like more general cards.
Okay.
So like 04 is only a register card, so that's why it starts with 0. Every other card has like the first digit is the speed, how fast it's supposed to be going. But yeah, it has like Reg 04 has 4 independent clocks, but if it's a set or reset for each of those register bits, is only 1 pin in for the set or 1 pin in for the reset.
All right, here we go. This is LD312, which I don't remember what that was.
The LD are mostly just like a full.
Oh, that's fun.
Actually, I don't know this one.
Christmas tree lights.
Yeah. I have 1 pin that toggles everything. The thing is like that. These were cards that were not in the machine, so like these could be bad as well. There could be faults on these. I mean, heck, we already found 2 faults on 2 cards, right?
LD312 is a lots of inputs, but it has like 1 common gate that can permit or not passage. It's a ginormous multiplexer that just selects or doesn't select.
A line driver?
Yeah. They also have line receivers, LR312.
Yeah, that's what's in there right now, I think. Yeah, so ultimately, I got to sit down and spend time with schematics and go through and just test cards. But the 27 and the 112, those are the easiest ones I can go, and that makes up like 50 cards or 60 cards.
The only suggestion is you might want to put silkscreen or equivalent.
On what?
For the switches, because
they're different. They're different for each card. So like silkscreen would be meaningless from one card to the next.
Just the pin number.
No, I got a better idea.
Oh, I got it.
Remember those little cardboard things you used to stick over a keyboard so you could remember which key did what in WordPerfect 5 or 4? No, it was 5.
Yeah, and the same for the TI-99. I get what you're putting down, but it's like this is pin 4, this is pin 40, and there's a lot of repetition, so it's pretty easy to figure out.
Yeah, in this case, you would just have to slip it over your switches and LEDs.
But what I mean is some of the boards like, oh, the only switch that does something is the 21st one. Right? Which one is that?
Yeah, but then for all of those boards, I just put a little, tick mark on that switch or whatever, right? And then I test all those boards, and then I erase that little tick mark. Like, there's no need to do anything permanent. And for the majority of the boards, it doesn't matter, like, because the pattern of the LEDs will tell you what goes where.
Yeah, but you could print a card for each card for each card you're going to test that has what each switch is and does.
Yeah, but I would spend
cards.
I would spend more time printing and cutting holes for those than I would spend just like memorizing what switches do what for each test.
Or maybe just for the complicated ones.
Yeah. The thing is like the complicated ones are not very many. So the ones that I'm really worried about are the ones that I don't think the switches are going to cover anyways.
Yeah.
And so we're going to have to get to different stuff for that.
And you don't have to cut holes. You could just make a rectangular box. So you got labels at the top and labels at the bottom.
Yeah.
But I would have just numbered them 1 through 37.
It's 4 through 40.
Yeah, 4 through 40. Yeah.
Yeah, and I may do that. I may mark off, with like a little Sharpie. I may mark off 10s. Like where switch 10, where switch 20, where switch 30, and where switch 40. Well, I know where switch 40 is. But if I mark off where 20, 30, and I'm like, oh, I need to get to switch 27, I just go to 30 and count back 3. Right.
Yeah. It's just some of the design are gonna require okay, and we're in the arithmetic one. It's pin 17 that works on this section. Where's 17 again?
Yeah. And then you just go to 20 and count back 3 and you're at 17.
Yeah.
Now, what's worse is when you think you know where it is, but you're off by 1, and then get sent down a rabbit hole.
Yeah.
Minimal amount of marking.
Yeah. The thing came out looking awesome though. I'm like super happy with how the thing looks.
Positively retro.
Yeah. The only thing I don't like are the like generic power supplies that I put on there. So maybe someday we'll rip those off and put a transformer with an actual regulator, plus minus regulator on it. Something period correct to the 1960s. All right, y'all. It's 1:30.
Yeah.
I'm going to bed. Thanks for joining. We'll see you next week. I'm going to order, I suppose, hop in the Friday Night Litton channel and just let me know what direction we need to head in for next week, and then I'll order the parts tomorrow or Sunday. It doesn't matter. And so that way we have parts to build with and test with for next week.
Yeah.
Yeah. All right, guys.
The fun part will be when your other capacitor gets here, you swap the capacitors, and the behavior completely changes for reasons we don't freaking understand.
Yeah. That's, I think, probably the first thing we're going to do next week is switch back down to the 4 microfarad. Get that 5 microfarad out there. Because the 4 microfarad that's coming should be the exact same form factor, so it should be able to bolt right in. But the 5 microfarad got us through to the end of the day today, which is pretty awesome.
Yep. All right. See y'all next week.
All right, guys.
Yeah.
Catch y'all later.
See ya.
Peace.